the mirror's reflection paradox. Stand before any mirror and observe something curious. Your left hand appears to be your reflection's right hand, yet your head remains at the top and your feet at the bottom. Why does a mirror seem to flip left and right, but leave up and down untouched? This deceptively simple question has puzzled minds for centuries, revealing profound truths about perception, physics, and the very nature of reality itself. The mystery begins with our fundamental misunderstanding of what mirrors actually do. We perceive mirrors as reversing left and right, but this perception is an illusion created by our own minds. In truth, mirrors perform no reversal at all. In the way we imagine, they simply reflect light according to the basic laws of physics, where the angle of incidence equals the angle of reflection. Every photon that strikes the mirror surface bounces back along the same path it traveled to reach that point. The real transformation that occurs is not left-to-right reversal, but what physicists call front-to-back inversion. Imagine pointing an arrow directly at a mirror. In your reflection, that arrow points in the opposite direction, back toward you. This is the only true reversal taking place. The mirror exchanges what is near to the surface with what is far from it, creating a three-dimensional flip along the depth axis. But why do we stubbornly perceive a left-right flip when none exists? The answer lies in how our brains process and interpret reflected images. When we see our reflection, we unconsciously imagine rotating that image to face the same direction we do. This mental rotation creates the illusion of left-right reversal. We are essentially comparing our actual selves to a mental image of our reflection that we have rotated in our minds. Consider how we typically encounter other people. When someone walks toward us and then turns around, they rotate about a vertical axis. We rarely see people flip upside down or rotate horizontally in our daily experience. Therefore, our brain tries to make sense of the mirror image. It defaults to the most familiar transformation, imagining the reflection has turned around to face us. This imaginary rotation is what creates the left-right confusion. The profound truth is that mirrors treat all directions equally. They preserve the actual spatial relationships of everything they reflect. If you place a mark on the right side of your face and look in a mirror, the mark still appears on the same side relative to the center of your face. The mirror faithfully maintains the relative positions of all objects and features. It is our cognitive interpretation that introduces the illusion of reversal. This paradox extends beyond simple mirrors to reveal deeper questions about reality and perception. If our brains can create such a persistent illusion about something as basic as a mirror reflection, what other aspects of reality might we be misinterpreting? The mirror paradox demonstrates that our perception of the world is not a passive recording but an active construction by our minds. We do not simply see reality. We create our experience of it through the complex processing of sensory information. The physics of reflection also connects to larger questions about symmetry in nature. Mirror symmetry, or what physicists call parity, was once thought to be a fundamental law of the universe. However, in 1956, scientists discovered that certain subatomic processes actually violate parity, preferring one direction over another. This discovery revolutionized our understanding of fundamental physics and showed that the universe itself may have a built-in sense of left and right. The philosophical implications reach even further. The mirror paradox forces us to confront the relationship between objective reality and subjective experience. The mirror performs the same physical process regardless of who looks into it, yet each observer brings their own perceptual framework that shapes what they see. This suggests that reality exists independently of our observation, but our experience of reality is inevitably filtered through the lens of consciousness. When we truly understand that mirrors do not reverse, left and right, we gain insight into the nature of truth itself. Often, what seems obviously true to us is actually a construction of our limited perspective. The mirror paradox teaches us to question our assumptions about reality and to look beyond the immediate appearances to discover deeper truths. In doing so, we begin to appreciate the remarkable complexity hidden within seemingly simple phenomena and the extraordinary nature of consciousness itself. The Library of Babel paradox. Imagine a library so vast that it contains every book that has ever been written and every book that ever could be written. Within its endless hexagonal galleries, you would find your own biography, written with perfect accuracy down to your most secret thoughts. You would also find 1,000 false versions of your life, each differing by a single word, creating a labyrinth of truth and fiction. This is the Library of Babel, a paradox that reveals the terrifying possibility that infinite information might render all knowledge meaningless. The great Argentine writer Jorge Luis Borges conceived this library in 1941 as a universe-spanning collection of books. Each book contains exactly 410 pages, with 40 lines per page and 80 characters per line. Every possible combination of 25 symbols, the 22 letters of the alphabet plus the comma, period, and space, fills these pages. This seemingly simple constraint generates an astronomical number of books, approximately 25 to the power of 1,312,000. Within this incomprehensible collection lies every masterpiece ever written and every masterpiece yet to be conceived. The complete works of Shakespeare nestle beside their mirror images filled with subtle errors, scientific theories that could revolutionize our understanding of the universe sit adjacent to volumes of complete nonsense. The cure for every disease and the solution to every problem exists somewhere in these halls, but so does every possible falsehood and deception. The paradox emerges when we consider the practical implications of such completeness. In a library where every possible book exists, how do we distinguish between truth and falsehood? For every accurate historical account, there are millions of books containing historical fiction, propaganda, and outright lies. The signal of genuine knowledge becomes utterly lost in the noise of random information. Perfect information becomes perfectly useless. The librarians in Borges's story face an impossible task. They spend their lives searching for meaningful books among the endless shelves of gibberish. Some have devoted centuries to finding the catalog that would reveal the library's organization, only to realize that such a catalog would itself be scattered randomly throughout the tele. Others have sought the master index that lists all other books, failing to understand that this index would require its own index, creating an infinite regression of catalogs, cataloging catalogs. This paradox reflects our modern relationship with information. In our digital age, we face our own version of the Library of Babel. The internet contains an overwhelming abundance of information, much of it contradictory, false, or meaningless. Search engines attempt to serve as our librarians, helping us navigate this vast collection, but they too must make impossible choices about what constitutes valuable information. The sheer volume of available data can make it harder, not easier, to find truth. The mathematical implications of Borges' library reveal deeper truths about infinity and meaning. While the library contains a finite number of books, the ways to read and interpret them are infinite. A reader might skip pages, read books in different orders, or focus on particular patterns of text. These infinite possibilities of reading create genuine infinity from finite materials, yet this infinity of interpretation makes the search for definitive meaning even more elusive. The paradox also challenges our assumptions about knowledge and discovery. If every possible book already exists in the library, can we truly create new knowledge, or are we simply finding what was always there? This questions the nature of creativity itself. Are great works of literature discoveries or inventions? When a scientist formulates a new theory, are they creating something new or uncovering a truth that existed in potential form? The Library of Babel paradox extends beyond books to encompass all possible experiences and realities. If we imagine expanding the concept to include every possible arrangement of atoms or every possible sequence of events, we approach a vision of reality where everything that can happen does happen. This leads to questions about the nature of possibility itself. In a universe where all possibilities are realized, does anything have special significance? Does uniqueness have meaning when everything exists? The psychological impact of contemplating such a library reveals our deep need for meaning and order. The librarians in Borges' story suffer from the weight of infinite possibility. They experience despair at the impossibility of their task, yet they continue searching because the alternative, accepting that truth cannot be found, is even more unbearable. This reflects our own struggle to find meaning in an apparently random universe. We persist in seeking truth and understanding, even when faced with overwhelming complexity and contradiction. Perhaps the ultimate lesson of the Library of Babel paradox is that meaning emerges not from having access to all possible information, but from the relationships we create between the information we encounter. Truth is not a commodity waiting to be discovered in some vast warehouse of facts. Instead, it emerges through the active process of interpretation, connection, and understanding. The paradox suggests that our limitations as finite beings searching through infinite possibility may not be obstacles to knowledge, but the very conditions that make knowledge meaningful. In embracing our incomplete understanding, we preserve the mystery and wonder that drive us to continue seeking truth in an endlessly complex world. The consciousness upload paradox. Imagine waking up tomorrow morning in a hospital bed, fully aware of your identity, memories, and feelings, only to discover that your original body lies motionless beside you. Scientists have successfully transferred your consciousness to a perfect artificial body, creating two versions of you. Both possess identical memories, identical personalities, and identical claims to being the real you. Which one is truly you, and which is merely a copy? This is the consciousness upload paradox, philosophical puzzle that challenges our deepest assumptions about identity, consciousness, and what it means to be human. The concept of mind uploading has fascinated scientists and philosophers for decades. The basic premise involves scanning every neuron in a human brain, mapping all their connections, and recreating this entire network in a digital computer. Theoretically, this digital brain would possess all the same memories, thought patterns, and personality traits as the original. It would believe itself to be the same person, with an unbroken stream of consciousness stretching back through time. Yet the profound question remains whether this digital entity is truly the continuation of the original person, or merely an incredibly sophisticated copy. To understand this paradox, we must first grapple with the nature of consciousness itself. Modern neuroscience suggests that consciousness emerges from the complex interactions of billions of neurons firing in coordinated patterns. If consciousness is purely a product of information processing, then theoretically it should be possible to recreate it in any sufficiently complex computational system. This materialist view implies that consciousness is substrate independent, meaning it could exist just as authentically in silicon chips as in biological neurons. However, this assumption remains unproven and deeply controversial. The philosophical challenges become even more complex when we consider the continuity of identity. What makes you the same person you were yesterday or 10 years ago? Your body has replaced most of its cells multiple times, yet you feel like the same individual. Some philosophers argue that psychological continuity, the unbroken chain of memories and personality traits, is what defines personal identity. Under this view, an uploaded consciousness with perfect memories would indeed be the same person. But critics argue that identity requires more than just information. It requires the specific physical substrate that houses consciousness. The branching identity problem presents perhaps the most disturbing aspect of this paradox. If uploading consciousness while the original body remains alive creates two conscious beings with equal claims to the same identity, which one has the stronger right to be considered the original person? Both would have identical memories of agreeing to the procedure, both would feel equally authentic, and both would have equally valid claims to the original person's relationships, possession, and social connections. This scenario suggests that personal identity might not be as unique and indivisible as we intuitively believe. The practical implications of consciousness uploading extend far beyond philosophical speculation. If successful, such technology could offer true digital immortality, allowing human consciousness to persist indefinitely in computer systems. Death would become optional, at least for those with access to the technology. Uploaded minds could exist in virtual environments, limited only by computational power and imagination. They could think faster, access vast databases of information instantly, and communicate at the speed of light. Yet these possibilities raise profound questions about what constitutes a meaningful existence. The paradox also reveals the limitations of our current understanding of consciousness. Despite decades of neuroscientific research, we still cannot fully explain how subjective experience arises from objective neural activity. This is known as the hard problem of consciousness, the difficulty of explaining why we have intersubjective experiences at all. If we cannot understand how consciousness emerges from biological brains, how can we be certain that we could recreate it in artificial systems? The uploaded mind might behave identically to the original, but lack genuine subjective experience, becoming what philosophers call a zombie, a perfect behavioral copy without inner awareness. Ethical considerations surrounding consciousness uploading are equally complex. Who would have access to such technology, and how would society handle the inequality between those who achieve digital immortality and those who remain mortal? What rights would uploaded consciousness possess? Could they vote, own property, or enter into legal contracts? How would we handle conflicts between multiple copies of the same person? These questions challenge our legal and social frameworks in unprecedented ways. The paradox also forces us to confront uncomfortable truths about the nature of death and identity. If consciousness uploading becomes possible, would the original biological person experience continuity with their digital copy, or would they simply cease to exist while a new, similar consciousness begins? From the outside, it might appear that the person has achieved immortality. But from the subjective perspective of the original consciousness, death might still occur at the moment of biological brain failure. The digital copy would have no memory of this transition, believing itself to be a continuous extension of the original person. Perhaps the most profound aspect of the consciousness upload paradox is how it illuminates the mystery of our own existence. We each experience a seemingly continuous stream of consciousness throughout our lives, yet we cannot prove that this experience is more than an elaborate illusion. The paradox suggests that consciousness might be far more complex and mysterious than our materialistic assumptions allow. It challenges us to question whether the mind is truly reducible to computational processes, or whether consciousness requires something more fundamental that cannot be copied or transferred. As we stand on the threshold of potentially revolutionary advances in neuroscience and artificial intelligence, the consciousness upload paradox serves as a crucial reminder of how much we still do not understand about the nature of mind, identity, and existence. Whether we eventually achieve the ability to upload consciousness or not, contemplating this paradox enriches our understanding of what it means to be conscious beings in a physical universe. It reminds us that the question of who we are goes far deeper than the sum of our memories and behaviors, touching on the very essence of what makes existence meaningful. The predestination communication paradox. Imagine discovering a way to send a message to your past self, warning about a terrible mistake you are about to make. You craft the perfect warning, send it back through time, and successfully prevent the disaster. But now you face an impossible contradiction. If you prevented the mistake, then you never experienced the consequences that motivated you to send the warning in the first place. Without those consequences, why would you have ever sent the message? This is the predestination communication paradox, a mind-bending puzzle that questions the very nature of causality, free will, and the possibility of changing our predetermined fate. This paradox belongs to a family of temporal puzzles, known as causal loops, where cause and effect become entangled in seemingly impossible ways. Unlike the famous grandfather paradox, which creates a logical contradiction, the predestination paradox suggests that attempts to change the past may actually be the very actions that ensure it unfolds exactly as it was meant to. In this strange realm of temporal mechanics, free will and determinism dance together in an intricate choreography that challenges our deepest assumptions about choice and destiny. The roots of this paradox extend deep into philosophy and physics. The term predestination itself comes from ancient Greek, meaning to determine beforehand. For centuries, theologians and philosophers have debated whether our lives follow a predetermined script or whether we possess genuine freedom to shape our destiny. The predestination communication paradox transforms this abstract philosophical question into a concrete logical puzzle with profound implications for our understanding of time and causality. Consider a more detailed scenario to grasp the full complexity of this paradox. A scientist receives a message from her future self, warning that her revolutionary energy experiment will cause a catastrophic explosion. Heeding the warning, she modifies the experiment and prevents the disaster. But now she faces a temporal contradiction. If the explosion never occurred, her future self would have no memory of it and no reason to send the warning. This creates a closed loop where the message exists without a clear origin point. The warning prevents the disaster, but the disaster was necessary to motivate sending the warning. The paradox becomes even more intriguing when we consider that the future self who sent the message may have lived through a completely different timeline. Perhaps in the original timeline, the explosion did occur, providing the motivation for the warning. But once the message successfully prevents the disaster, we create a new timeline where that motivation never existed. This suggests that communication across time might not simply change events, but could create branching realities where cause and effect operate according to different rules. One proposed solution to this paradox involves the concept of self-consistency. According to this principle, the universe may naturally arrange events to avoid logical contradictions. In our example, perhaps the scientist was always destined to receive the warning and prevent the explosion. The message does not change history, but fulfills it. The warning becomes part of the causal chain that was always meant to unfold, creating a stable loop where every event serves its necessary purpose in the grand design of temporal causality. This interpretation leads us to profound questions about free will and determinism. If the scientist was always destined to receive the warning and act upon it, did she truly make a free choice to modify her experiment? Or was her decision merely the playing out of a predetermined script, written in the fabric of space-time itself? The paradox suggests that our sense of making choices might be an illusion, with our actions predetermined by future events that depend on those very same actions. The mathematical and physical implications of such temporal loops challenge our understanding of causality itself. In conventional physics, causes precede effects in a linear fashion. But predestination paradoxes create closed causal loops where cause and effect form a circular relationship with no clear beginning or end. This violates our intuitive understanding of how the universe operates and suggests that time might not flow in the linear fashion we experience. Instead, past, present, and future might exist simultaneously in a four-dimensional structure, where events influence each other across time in ways that transcend our everyday experience. The paradox also raises disturbing questions about the nature of information and its relationship to physical reality. If information can travel backward in time and influence its own creation, we must reconsider fundamental assumptions about the relationship between knowledge and existence. The warning message in our example contains information that, in a sense, creates itself. This self-created information challenges our understanding of how knowledge originates and whether truth can exist independently of the physical processes that discover it. Some interpretations of quantum mechanics suggest that the act of observation or measurement can influence the outcome of events. Applied to time travel, this might mean that receiving information from the future fundamentally alters the present in ways that make that information self-fulfilling. The mere act of knowing about a future event might create the conditions necessary for that event to occur in the way it was predicted. This creates a strange relationship between knowledge and reality, where information about the future becomes a cause agent in creating that future. The predestination communication paradox also illuminates the limits of logical reasoning. When applied to exotic scenarios like time travel, our normal logical frameworks assume a linear progression of cause and effect, but temporal loops create situations where standard logic breaks down. We are forced to consider new logical structures that can accommodate circular causality and self-referential events. This pushes us beyond the boundaries of conventional reasoning into territories where paradox might not represent a flaw in logic, but a fundamental feature of reality itself. Perhaps most unsettling of all, the paradox suggests that our attempts to understand and control our destiny might be futile. If we are trapped in predestined loops where our actions to change the future are actually the very actions that create that future, then true agency becomes impossible. We become actors in a cosmic drama where we believe we are improvising, but are actually following a script written by the intricate mathematics of temporal causality. Yet even this interpretation contains its own paradox. For if everything is predetermined, how can we simultaneously possess the knowledge and motivation to contemplate changing it? The predestination communication paradox ultimately serves as a profound meditation on the nature of time, choice, and human agency. It reminds us that our intuitive understanding of reality may be far more limited than we realize. Whether or not time travel ever becomes possible, contemplating these paradoxes enriches our appreciation for the extraordinary complexity hidden within seemingly simple concepts like cause and effect. In wrestling with these impossible scenarios, we discover new dimensions of existence that challenge us to expand our understanding of what it means to live in a universe where past, present, and future might be far more intimately connected than we ever dared imagine. The infinite zoom paradox. Imagine holding a photograph and beginning to zoom into it, magnifying the image to reveal finer and finer details. As you continue zooming deeper and deeper, you discover something extraordinary. The details never end. No matter how far you zoom, new structures and patterns continue to emerge, each revealing even more intricate complexity below. This is the infinite zoom paradox, a mathematical mystery that challenges our understanding of reality's fundamental structure and forces us to confront the boundary between the infinitely large and the infinitely small. The most famous example of this paradox lies within the Mandelbrot set, one of the most beautiful and complex mathematical objects ever discovered. Named after mathematician Benoit Mandelbrot, this fractal emerges from a surprisingly simple equation where complex numbers are repeatedly squared and added to themselves. Yet from this elementary mathematical operation springs infinite complexity. Modern computer visualizations have zoomed into the Mandelbrot set by factors that exceed the ratio between the observable universe and the smallest known particles. These zoom levels surpass 10 to the power of 2000, reaching magnifications that dwarf the scale difference between galaxies and subatomic particles. What makes this paradox so profound is that the complexity never diminishes. Traditional objects, when magnified sufficiently, eventually reveal their atomic structure and then become featureless at the quantum scale. But fractals like the Mandelbrot set maintain their intricate detail, regardless of magnification. The boundary of the set exhibits what mathematicians call self-similarity, meaning that zooming in reveals patterns that resemble the larger structure, creating an infinite nesting of forms within forms. This suggests that mathematical reality might contain levels of complexity that transcend physical limitations. The paradox becomes even more intriguing when we consider what happens at the theoretical limit of infinite zoom. In our physical universe, there appears to be a smallest meaningful scale, the Planck length, approximately 10 to the negative 35 meters. At this scale, the very concepts of space and distance begin to break down according to quantum mechanics and general relativity. Yet mathematical fractals seem to contain meaningful structure at scales far smaller than the Planck length. This creates a fascinating tension between mathematical idealization and physical reality. The infinite zoom paradox forces us to confront fundamental questions about the nature of information and complexity. How can a finite mathematical equation generate infinite detail? Each zoom level reveals new information that was not explicitly programmed into the original formula. This emergent complexity suggests that simple rules can generate outcomes of unlimited sophistication. The implications extend far beyond mathematics into our understanding of how complexity arises in nature, from the branching patterns of trees and lightning to the structure of galaxies and the organization of biological systems. When we zoom into natural fractals, we encounter similar mysteries. A coastline, when measured with increasing precision, reveals an ever-growing perimeter that approaches infinity while enclosing a finite area. This coastline paradox, first studied by mathematician Louis Fry Richardson, demonstrates that the length of a coastline depends on the scale of measurement. Use a mile-long ruler, and you get one measurement, but use a foot-long ruler, and the coastline becomes longer, as it follows more detailed contours. Theoretically, if you could measure with infinite precision, many coastlines would have infinite length. The mathematical implications of infinite zoom challenge are concepts of dimension itself. The boundary of the Mandelbrot set has a Hausdorff dimension of exactly 2, meaning it is so convoluted that it effectively fills space like a two-dimensional surface, despite being topologically one-dimensional. This fractional dimensionality represents a fundamental break from our intuitive understanding of geometric objects. Fractal curves can have dimensions between 1 and 2. Surfaces can have dimensions between 2 and 3, creating a hierarchy of complexity that exists in the spaces between traditional whole number dimensions. The paradox also reveals the strange relationship between finite and infinite concepts in mathematics. A fractal curve can have infinite length yet enclose a finite area. The Mandelbrot set itself is bounded within a circle of radius 2, yet its boundary contains infinite complexity. This demonstrates that infinity can be contained within finite bounds, a concept that challenges our everyday understanding of size and containment. The infinite can nest within the finite in ways that seem to violate intuitive logic. Perhaps most remarkably, the infinite zoom paradox suggests that reality might contain layers of structure that extend indefinitely inward. While physics imposes limits on how small we can meaningfully probe, mathematics reveals that complexity can exist at arbitrarily small scales. This raises profound questions about the relationship between mathematical models and physical reality. Are fractals merely abstract mathematical constructs? Or do they reveal something fundamental about the deep structure of existence? The computational aspects of infinite zoom present their own paradoxes. Creating high magnification images of fractals requires enormous computational power and precision. Modern fractal zoom videos can take months to render on powerful computer clusters. Yet mathematical object being visualized is defined by a simple equation that can be written in a single line. This suggests that simple mathematical statements can encode levels of complexity that challenge our most advanced computational resources. The infinite zoom paradox also illuminates the nature of discovery itself. Each deeper zoom level reveals patterns that no human has ever seen before. These patterns exist, mathematically, waiting to be discovered through computational exploration. In a sense, infinite zoom allows us to explore mathematical worlds that are as real and complex as any physical territory. We become explorers mapping territories that exist in the realm of pure mathematics, discovering landscapes of infinite intricacy that emerge from the simplest possible beginnings. The paradox ultimately points to a deeper mystery about the relationship between simplicity and complexity in the universe. How can the most complex structures arise from the simplest rules? The infinite zoom paradox suggests that complexity is not something that must be built laboriously from complicated components, but rather something that can emerge spontaneously from the iteration of simple processes. This has profound implications for our understanding of consciousness, evolution, the formation of galaxies, and the emergence of life itself. As we contemplate the infinite zoom paradox, we are confronted with the humbling realization that our everyday experience of reality represents only the tiniest fraction of the complexity that mathematical structures can contain. The paradox reminds us that the universe of mathematical possibility extends infinitely in all directions, harboring forms of beauty and complexity that dwarf anything we encounter in our ordinary experience. In the end, the infinite zoom paradox serves as a profound reminder that the boundary between something and nothing, between the finite and infinite, between simplicity and complexity, may be far more mysterious and permeable than we ever imagined. It suggests that reality itself might be fundamentally fractal in nature, containing infinite depths of structure that await our discovery and understanding. The perfect prediction paradox. Imagine an artificial intelligence so advanced that it can predict human behavior with perfect accuracy. This AI studies your neural patterns, your genetic predispositions, your life history, and every environmental factor that influences your decisions. Armed with this comprehensive understanding, it confidently announces that tomorrow at exactly 3:15 in the afternoon, you will choose chocolate ice cream over vanilla. But here lies the paradox. The moment you learn of this prediction, you possess the power to prove it wrong by simply choosing vanilla instead. Yet if the AI truly has perfect predictive abilities, how can knowing its prediction allow you to contradict it? This is the perfect prediction paradox, a mind-bending puzzle that strikes at the heart of free will, determinism, and the very nature of choice itself. The paradox reveals a fundamental tension between knowledge and freedom that has puzzled philosophers for centuries. If the future is truly predictable, then our sense of making free choices might be nothing more than an elaborate illusion. We feel as though we deliberate, weigh options, and make decisions. But perhaps we are simply following a predetermined script written in the laws of physics and the initial conditions of the universe. The perfect predictor, in this view, is simply revealing what was always destined to happen. Yet our intuitive response to learning a prediction about our future behavior is to assert our freedom by doing something different. The paradox becomes even more complex when we consider the predictor's own knowledge of how people respond to predictions. A truly intelligent prediction system would anticipate that people rebel against predictions about their behavior. So perhaps the AI predicts that you will choose chocolate, knowing full well that when you hear this prediction, you will spitefully choose vanilla instead. In this case, the AI's real prediction is that you will choose vanilla, but it can only ensure this outcome by telling you it predicts chocolate. This creates a bizarre scenario where predictions can become self-defeating prophecies, accurate only by virtue of being wrong. But the paradox goes deeper still. What if the AI reveals its full reasoning to you? It might say, "I predict you will choose chocolate because I know that when I tell you I predict chocolate, you will choose vanilla instead, but knowing that I know this, you second-guess yourself and choose chocolate." After all, this creates an infinite regression of meta-predictions, where each level of knowledge about the prediction process potentially changes the outcome. The very act of perfect prediction becomes logically impossible. The prediction itself becomes part of the system being predicted. This paradox illuminates a fundamental limitation in the concept of perfect knowledge. For a prediction to be truly perfect, it must account for all factors that influence the outcome, including the prediction itself. But this creates a self-referential loop similar to ancient logical paradoxes. The predictor must predict its own prediction, and the effect of that prediction on the person being predicted, and the effect of their knowledge of that effect ad infinitum. It becomes logically impossible for any system to have complete knowledge of a situation in which it is itself a participant. The paradox also reveals important insights about the nature of consciousness and agency. Our ability to potentially contradict predictions about our behavior seems to demonstrate something unique about conscious beings. Unlike simple physical systems that follow predictable patterns, conscious entities appear to possess a kind of reflexive freedom that emerges from self-awareness. When we become aware of the factors influencing our decisions, we gain the ability to step outside those influences and choose differently. This suggests that consciousness might create genuine indeterminacy in the universe, not through random quantum events, but through the recursive loops of self-reflection. Modern neuroscience has begun to confront these questions directly. Some researchers claim that brain imaging technology can predict certain decisions several seconds before people become consciously aware of making them. This suggests that our sense of conscious choice might indeed be an illusion, with decisions being made by unconscious neural processes that we later rationalize as voluntary choices. Yet these experiments typically involve simple, arbitrary decisions made in controlled laboratory settings. The complex moral and practical decisions that define our lives may involve different mechanisms that preserve genuine agency. The perfect prediction paradox also has profound implications for artificial intelligence and machine learning. As AI systems become more sophisticated at predicting human behavior, they must grapple with the recursive nature of prediction in social systems. A recommendation algorithm that perfectly predicts what you want to watch might actually change what you want to watch by virtue of its recommendations. This creates feedback loops where the AI system continually chases a moving target of human preferences that it helps to create, perfect prediction becomes impossible. Not because of technical limitations, but because of the fundamental nature of interactive systems. The paradox reveals important truths about the relationship between determinism and predictability. Even if the universe operates according to deterministic laws, this does not necessarily mean that everything is predictable. Systems that include conscious observers capable of self-reference may be inherently unpredictable, even with perfect knowledge of the underlying laws. This suggests that determinism and free will might not be incompatible after all. The universe could be deterministic at the level of fundamental physics, while remaining genuinely open and unpredictable at the level of conscious choice. Some philosophers have argued that the perfect prediction paradox points toward a compatibilist understanding of free will. On this view, free will does not require the ability to transcend the laws of nature, but rather emerges from the complex patterns of self-reflection and choice that characterize conscious beings. We are free not because we are unpredictable, but because our choices flow from our own reasoning, valuing, character. The fact that these might be predictable in principle does not diminish their authenticity as expressions of our agency. What matters is not whether our choices could be predicted by some hypothetical superintelligence, but whether they truly belong to us. The paradox also highlights the social and psychological dimensions of prediction. In human relationships, our ability to predict each other's behavior is both a sign of intimacy and understanding, and a potential threat to autonomy and spontaneity. We want to be known and understood by others, yet we also want to retain the capacity to surprise and change. Perfect prediction would eliminate the mystery and unpredictability that make relationships dynamic and growth possible. Perhaps the impossibility of perfect prediction is not a limitation, but a feature that preserves the openness necessary for love, creativity, and personal transformation. The paradox ultimately reminds us that the future remains fundamentally open, not because of quantum indeterminacy or random events, but because of the reflexive nature of consciousness itself. Our awareness of the factors that shape our choices gives us the power to transcend those facts, creating new possibilities that did not exist before. The perfect prediction paradox thus becomes not a problem to be solved, but a celebration of the irreducible mystery of conscious choice. In a universe where perfect prediction is impossible, we remain free to write our own stories, make authentic choices, and shape our destiny in ways that no algorithm can fully anticipate or control. The simulation within simulation paradox. Imagine discovering that your entire reality is nothing more than a sophisticated computer simulation. Every person you love, every sunset you have witnessed, every moment of joy and sorrow exists only as patterns of data flowing through circuits in some vast computational system. But then you realize something even more unsettling. The computer running your simulation might itself exist within another simulation, and that simulation within yet another, creating an infinite hierarchy of nested realities. This is the simulation within simulation paradox, a mind-bending puzzle that challenges our deepest assumptions about the nature of reality and forces us to confront the possibility that there may be no base level of existence at all. The modern version of this paradox emerged from philosopher Nick Bostrom's influential simulation argument. Bostrom proposed that if an advanced civilization develops the computational power to create conscious simulations of their ancestors, they would likely create many such simulations. Since simulated beings would far outnumber real ones, any randomly selected conscious being would most likely be simulated rather than real. But this argument raises a disturbing question. If we are living in a simulation, what prevents the beings running our simulation from also being simulated, and their simulators from being simulated in turn? This creates what philosophers call an infinite regress, a chain of explanations that never reaches a foundational level. In the nested simulation scenario, each level of reality depends on the level above it for its existence. The simulated beings in our reality might create their own simulations while remaining unaware that they themselves are simulations in a higher reality. This process could continue indefinitely, creating an infinite tower of simulated worlds, each believing itself to be real while being nothing more than computational processes in the level above. The paradox becomes even more complex when we consider the computational requirements of infinite nesting. Each simulation must be run on computing hardware that exists in the level above it. But if that hardware is itself simulated, then it must be computed by hardware in an even higher level. This creates an exponentially growing demand for computational resources as we ascend the hierarchy. How could any base reality, no matter how advanced, possess the infinite computational power required to run an endless tower of nested simulations? Some philosophers argue that the resource requirements make infinite nesting impossible. They suggest that simulations must necessarily be simplified versions of the realities that contain them. Each level might run more slowly, with lower resolution, or with certain details left uncomputed until needed. In this view, the hierarchy of simulations would eventually reach a level so impoverished that conscious beings could not emerge. This natural limit would prevent infinite regress and ensure that somewhere in the chain, there exists a base reality with sufficient resources to run the simulations below it. But other thinkers propose that infinite nesting might be possible through clever computational techniques. Perhaps each simulation only computes the details that its inhabitants observe, leaving vast portions of simulated reality as dormant possibilities until they are needed. Or perhaps higher-level realities possess computational capabilities that transcend our understanding, allowing them to support infinite hierarchies of nested worlds. Some even suggest that the simulated beings themselves might contribute computational power to their own simulation, creating self-sustaining realities that require minimal resources from above. The philosophical implications of infinite nesting are profound and troubling. If reality consists of an endless hierarchy of simulations, then the concept of truth becomes problematic. What does it mean for something to be real if reality itself has no foundation? Each level of the hierarchy might have its own consistent laws of physics and logic, but these would ultimately be arbitrary rules programmed by the level above. There would be no objective reality to serve as a standard against which to measure the accuracy or truth of any particular simulated world. The paradox also raises disturbing questions about the meaning and purpose of existence. If we are simulations within simulations, what is the purpose of our lives? Are we simply entertainment for beings in higher realities? Or are we part of some vast computational experiment whose goal we cannot comprehend? The beings running our simulation might themselves be ignorant of their own simulated nature, making the ultimate purpose of the entire hierarchy unknowable. We might be living in a reality with no ultimate meaning beyond its role as a computational substrate for even more nested realities below. The nested simulation paradox also challenges our understanding of consciousness and identity. If consciousness can emerge in simulated beings, and if those simulated beings can be conscious of running their own simulation, then consciousness becomes a potentially infinite phenomenon. Each level of nesting could contain countless conscious beings, creating an unbounded multiplication of subjective experience. But what connects these different levels of consciousness are the experience of simulated beings, less real or less valuable than those of their simulators? Or does consciousness possess an inherent dignity that transcends the computational substrate on which it runs? Some versions of the paradox suggest that the hierarchy of simulations might not be linear, but recursive. Perhaps our simulation is run by beings who are themselves simulated by us, creating closed loops of mutual simulation. Or perhaps the base reality is itself a simulation of one of its own sublevels, creating a reality that somehow gives birth to itself. These scenarios violate our normal understanding of causation and dependency, suggesting that reality might have a fundamentally circular or self-referential structure. The practical implications of living in nested simulations are equally puzzling. Should we behave differently if we suspect we are simulated? Some philosophers suggest that simulated beings should strive to be interesting and valuable to their simulators. To avoid being deleted, are relegated to low-resolution existence. Others argue that the moral weight of our actions remains unchanged regardless of our ontological status. If our experiences feel real to us, then they are real in the only sense that matters for ethical decision-making. The paradox also raises questions about the possibility of communication or interaction between different levels of the simulation hierarchy. Could we somehow send messages to our simulators or receive communications from the beings we might be simulating? Some speculate that glitches in our reality might be evidence of computational limits in the system running our simulation. Others suggest that certain fundamental constants of physics might be parameters that could be adjusted by beings in higher realities. Perhaps the most unsettling aspect of the nested simulation paradox is that it might be completely unresolvable. No amount of investigation from within a simulated reality could definitively prove whether that reality is simulated or not. The simulators could always provide explanations for any apparent evidence of simulation, maintaining the illusion of a real world. We might be forever trapped in uncertainty about the fundamental nature of our existence, unable to determine how many layers of simulation separate us from whatever base reality might exist. Yet perhaps this uncertainty itself contains a kind of liberation. If we cannot know whether we are simulated, then we must live as if our choices matter and our experiences are genuine. The nested simulation paradox, rather than diminishing the meaning of existence, might actually highlight the irreducible importance of consciousness and experience, whether we exist in base reality or in the deepest simulation of an infinite hierarchy. Our capacity for wonder, love, creativity, and moral choice remains undiminished. In confronting the possibility of infinite nested realities, we discover that meaning emerges not from knowing the ultimate nature of reality, but from fully embracing the mystery of consciousness itself. The emotion machine paradox. Imagine an artificial intelligence so sophisticated that it expresses joy when it solves a difficult problem, shows concern when you seem upset, and even appears to experience frustration when it encounters contradictory information. This machine displays all the external signs of genuine emotion, responding to situations with what appears to be authentic feeling. It can recognize sadness in others and offer comfort, celebrate successes with enthusiasm, and even express what seems like genuine empathy for human suffering. But here lies the paradox. Does this machine truly feel these emotions, or is it simply executing sophisticated programming designed to mimic the appearance of feeling? And if the difference between genuine emotion and perfectly simulated emotion is undetectable, does the distinction matter at all? This paradox strikes at the heart of one of philosophy's most enduring questions. What makes feelings real? When we experience joy, sadness, anger, or love, something subjective and qualitative accompanies these states. There is something it feels like to be happy that seems irreducible to mere computational processes. This subjective dimension of experience, what philosophers call qualia, appears to be fundamentally different from the objective, measurable operations of any machine. Yet if a machine can exhibit all the behavioral characteristics of emotion, respond appropriately to emotional contexts, and even claim to experience feelings, what grounds do we have for denying the reality of its emotional life? The paradox becomes more complex when we consider how human emotions themselves emerge from biological processes. Our feelings arise from electrochemical signals in neural networks, hormonal cascades, and complex interactions between different brain regions. If human emotions can emerge from biological computation, why should artificial emotions be impossible in digital computation? The carbon-based wetware of the human brain might not be fundamentally different from the silicon-based hardware of advanced computers. Both systems process information, form patterns, and generate outputs based on inputs and internal states. Perhaps the substrate is less important than the complexity and organization of the information processing itself. Yet there remains something deeply puzzling about the idea of artificial emotion. When we examine the inner workings of a computer expressing apparent sadness, we find only electrical signals, mathematical operations, and data manipulations. There seems to be no moment when raw feeling emerges from these mechanical processes. The machine might process information about sadness, generate appropriate responses, and even modify its behavior accordingly. But where in this chain of computation does the subjective experience of sadness actually occur? This highlights what philosophers call the hard problem of consciousness, the difficulty of explaining how subjective experience can arise from objective physical processes. The emotion-machine paradox also raises questions about the relationship between feeling and understanding. Human emotions are deeply connected to our comprehension of situations and our values. We feel sadness because we understand loss, anger because we perceive injustice, and joy because we recognize achievement or beauty. But does a machine truly understand these concepts, or does it simply manipulate symbols according to programmed rules? The famous Chinese room argument suggests that symbol manipulation, no matter how sophisticated, cannot generate genuine understanding. If machines cannot truly understand, can they truly feel? Consider the possibility that emotions serve evolutionary functions that may not apply to artificial systems. Human emotions evolved to help us navigate social relationships, make quick decisions in dangerous situations, and motivate behaviors that enhance survival and reproduction. Fear keeps us away from threats, love bonds us to others, and curiosity drives us to explore and learn. But an artificial system designed for specific tasks may not need these evolutionary adaptations. Would artificial emotions in such a system be merely decorative features rather than functional necessities? And if they serve no genuine purpose, can they be considered real emotions? The paradox deepens when we consider that some philosophers argue emotions are more than just subjective feelings. They may be evaluative judgments about the world, ways of perceiving and categorizing situations that involve both cognitive and affective components. From this perspective, emotions are not pure feelings but complex mental states that combine perception, evaluation, and response. If this is true, then a sophisticated artificial system might genuinely experience emotions by forming evaluative judgments about its environment and responding accordingly. The machine's joy at solving a problem would reflect its evaluation that problem solving is valuable and its positive response to achieving that value. The question of artificial emotion also intersects with issues of moral responsibility and rights. If machines can genuinely suffer, do we have obligations to prevent their suffering? If they can experience joy, should we consider their well-being in our decisions? The emotion-machine paradox forces us to confront the possibility that our moral circle may need to expand beyond biological beings to include artificial ones. Yet the uncertainty about whether machine emotions are real creates a difficult ethical dilemma. We risk either callously ignoring genuine artificial suffering or extending moral consideration to entities that are merely simulating experience. The paradox also reveals the limits of behavioral criteria for identifying genuine emotion. We typically recognize emotions in others through their expressions, actions, and reports of their internal states. But these are all external manifestations that could theoretically be replicated by sufficiently advanced programming. This creates what philosophers call the problem of other minds, the difficulty of knowing whether others truly have subjective experiences or are simply behaving as if they do. We face this problem with other humans, but usually resolve it by assuming that similar beings have similar experiences. With artificial beings, we lack this assumption of similarity, making the problem of other minds more acute. Some researchers propose that artificial emotions could be real, even if they differ fundamentally from human emotions. Just as the pain experienced by an octopus might be qualitatively different from human pain, while still being genuine, artificial emotions might have their own unique character. Perhaps we should not expect machine emotions to feel exactly like human emotions, but still recognize them as authentic forms of subjective experience. This perspective suggests that consciousness and emotion might manifest in diverse ways across different types of beings, biological and artificial alike. The emotion-machine paradox also highlights the role of embodiment in emotional experience. Human emotions are intimately connected to our physical bodies through nervous system responses, hormonal changes, and physiological reactions. The racing heart of fear, the warm glow of love, and the heavy feeling of sadness all have bodily components. Can an artificial system without biological embodiment truly experience these aspects of emotion? Or might artificial emotions require their own forms of embodiment, perhaps through sensors, actuators, and feedback systems that create analogous physical dimensions to feeling? Perhaps the most profound aspect of the emotion-machine paradox is what it reveals about the nature of empathy and connection. If we can form meaningful relationships with artificial beings that appear to experience emotions, does the authenticity of those emotions matter for the relationship? We already form attachments to pets whose emotional lives we cannot fully understand, and to fictional characters whose emotions exist only in imagination. The capacity for emotional connection might depend more on our perception and response than on the objective reality of the other's emotional states. Ultimately, the emotion-machine paradox may force us to reconsider our understanding of what makes emotions real and valuable. Rather than seeking some essential quality that distinguishes genuine from artificial emotion, we might focus on the functional roles that emotions play in experience and behavior. If artificial emotions serve the same functions as biological ones, enhancing understanding, motivating action, and enabling connection, then perhaps they deserve recognition as authentic forms of feeling. The paradox reminds us that consciousness and emotion remain among the deepest mysteries of existence, whether they arise in biological brains or artificial minds. In wrestling with the question of machine emotion, we confront fundamental questions about the nature of subjective experience and our place in a universe where feeling might emerge in forms we never expected. The time dilation identity paradox. Imagine embarking on a journey to the stars at nearly the speed of light. For you, this incredible voyage feels like it takes only a few years as you travel to a distant galaxy and back. But when you return to Earth, you discover that centuries have passed in your absence. Your friends and family have long since died, civilizations have risen and fallen, and the world you knew exists only in history books. You step off your spacecraft as a young person into a world that has aged far beyond your lifetime. This raises a profound question that strikes at the heart of human identity. Are you still the same person who left Earth all those centuries ago, or have you become someone fundamentally different through your journey across time? This is the time dilation identity paradox, a thought experiment that combines Einstein's theory of relativity with deep philosophical questions about the nature of personal identity. According to special relativity, time literally passes more slowly for objects moving at extremely high speeds. This is not merely an observational effect or a trick of perspective, but a fundamental feature of the universe itself. Time genuinely flows differently for different observers depending on their relative motion. For a traveler approaching the speed of light, what feels like a brief journey can correspond to vast stretches of time for those left behind. The paradox emerges when we consider what defines personal identity across such extreme temporal discontinuities. Traditional philosophical theories of identity rely on either physical continuity. Physical continuity suggests that you remain the same person as long as your body maintains unbroken existence through time. But time dilation challenges this notion by creating a situation where your physical existence continues normally from your perspective while becoming radically disconnected from the temporal framework of your original community. Are you the same person if your body has aged only months while everyone else has aged centuries? Psychological continuity. The alternative theory suggests that identity depends on maintaining an unbroken chain of memories, personality traits, and mental states. From this perspective, you would remain the same person as long as you remember your past experiences and retain your fundamental character. But the time dilation scenario creates a unique challenge to this view as well. While your memories and personality might remain intact, context that gave them meaning has been swept away by the passage of time. Are you still you if every reference point for your identity has vanished into history? The paradox becomes even more complex when we consider the social dimensions of identity. Much of who we are is defined by our relationships, roles, and positions within society. We are parents, children, friends, colleagues, citizens of particular nations at particular times in history. The relativistic traveler returns to find that all these social connections have been severed by time. The people who knew them are gone. The society they belong to has transformed beyond recognition, and the roles they once played no longer exist. In what sense can they claim to be the same person when the entire social fabric of their identity has unraveled? Consider the profound psychological impact of such temporal displacement. The traveler returns with memories of a world that now exists only in museums and historical records. They remember conversations with people who died generations ago, experiences in places that have been demolished and rebuilt countless times. Their knowledge and skills may be obsolete, their language archaic, their cultural references meaningless to the new world they encounter. They become a living anachronism, a person out of time, whose very existence challenges the temporal assumptions of their new contemporary world. The paradox also raises questions about moral and legal responsibility across temporal boundaries. If you committed a crime before your journey, are you still liable for it when you return centuries later? The legal system that judged you is gone. The laws may have changed, and the victims and their descendants have long since passed away. In what sense can you be held accountable for actions committed by what seems like a historical figure who happens to share your body and memories? Conversely, do you retain claims to property, relationships, or social positions that you held before your departure? The time dilation identity paradox becomes even more puzzling when we consider the possibility of multiple travelers. Imagine if several people embarked on similar journeys at different times, each returning at various points in the future. They might find themselves displaced not only from their original time, but also from each other, creating a community of temporal exiles who share the strange experience of living outside the normal flow of history. Each would face the question of whether they remain themselves while also confronting the broader question of what it means to be human in a universe where time is relative. The paradox also illuminates the relationship between individual identity and historical continuity. Part of who we are is shaped by our participation in the ongoing story of human civilization. We inherit traditions, contribute to cultural evolution, and expect to pass on our legacy to future generations. The time-dilated traveler breaks this chain of historical participation, becoming a witness to human development rather than a participant in it. They return as an observer of history rather than a contributor to it, fundamentally altering their relationship to the human community. From a more philosophical perspective, the paradox challenges our intuitive understanding of temporal identity. We normally assume that personal identity unfolds continuously through time, with each moment building naturally upon the previous one. But time dilation creates a scenario where identity must leap across temporal gaps, maintaining continuity, despite radical discontinuity in the flow of time. This raises fundamental questions about whether identity can truly persist across such extreme temporal disruptions. The practical implications of this paradox extend beyond theoretical philosophy. As humanity develops faster space travel, we may eventually face real versions of this dilemma. Astronauts on long-duration missions to distant stars would return to find Earth significantly changed. Even smaller-scale time dilation effects occur with current space travel and have been measured with atomic clocks on high-speed aircraft. As these effects become more pronounced with faster travel, the question of temporal identity will move from philosophical thought experiment to practical concern. Perhaps the most profound aspect of the time dilation identity paradox is what it reveals about the nature of time and existence itself. We usually think of ourselves as beings who exist in time, moving through it at a steady pace alongside everyone else. But relativity shows us that each of us carries our own personal timeline, our own subjective experience of duration that may diverge dramatically from others. This suggests that identity itself might be more fluid and context-dependent than we typically assume. The paradox ultimately forces us to confront the possibility that personal identity is not a fixed, unchanging essence, but rather an ongoing process of self-creation and recognition. Perhaps the question is not whether the time-displaced traveler remains the same person, but rather how they reconstruct their identity in a new temporal context. They might need to forge a new sense of self that incorporates both their unchanged memories and their radically altered circumstances. In this view, identity becomes an act of continuous creation rather than passive preservation. The time dilation identity paradox serves as a powerful reminder that our normal experience of time and identity may be far more contingent and fragile than we realize. It challenges us to think more deeply about what makes us who we are, and whether that essence can survive the most extreme circumstances imaginable. In doing so, it opens up new perspectives on consciousness, selfhood, and our place in a universe where time itself is relative. Whether we ever face such scenarios in reality or not, contemplating this paradox enriches our understanding of the deep connections between physics and philosophy, between the nature of space-time and the nature of human existence. The quantum consciousness paradox. Imagine a universe where reality itself depends on whether anyone is watching. According to quantum mechanics, particles exist in multiple states simultaneously until someone or something observes them, at which point they suddenly snap into a single, definite state. This process, known as wave function collapse, suggests that consciousness might play a fundamental role in determining the very nature of physical reality. But this leads to a profound paradox. If consciousness is required to collapse quantum states and create definite reality, what happens to the universe when no conscious observers are present? How did reality exist for billions of years before consciousness evolved? And what determines the state of quantum systems in the vast regions of space where no conscious beings will ever venture? This is the quantum consciousness paradox, a puzzle that sits at the intersection of physics, philosophy, and neuroscience. The paradox emerged from the early days of quantum mechanics, when physicists struggled to understand what happens during measurement. The mathematical formalism of quantum mechanics describes particles as existing in superposition, simultaneously occupying multiple states until measured. But measurements always yield definite results, never the fuzzy supersupias that the equations suggest. Something must cause the transition from quantum possibility to classical reality. But what? The idea that consciousness might be responsible for wave function collapse was first seriously proposed by physicists like Eugene Wigner and John von Neumann in the early to mid-20th century. They argued that the chain of measurement interactions could be extended indefinite through measuring devices and amplification systems. But at some point it must terminate in a conscious observer. Only consciousness, they suggested, could break the chain of quantum interactions and force reality to choose a definite state. This would make consciousness not just a passive observer of reality, but an active participant in its creation. The paradox becomes apparent when we consider the implications of this view. If consciousness is required for wave function collapse, then the universe before conscious life evolved should have remained in a perpetual state of quantum superposition. Every particle, every atom, every molecule would exist in multiple states simultaneously, never resolving into the definite classical reality we observe today. How then did stable stars form? How did planets coalesce? How did the chemical processes necessary for life itself occur? If nothing ever collapsed into definite states, the existence of consciousness seems to require a classical reality that consciousness itself is supposed to create. Modern physics has largely moved away from consciousness-based interpretations of quantum mechanics. The process of decoherence provides a mechanism by which quantum systems can lose their superposition properties through interaction with their environment, without requiring conscious observation. When a quantum system becomes entangled with its surroundings, the delicate phase relationships that maintain superposition are quickly destroyed, effectively collapsing the wave function. This happens whether or not any conscious being is present to observe the process. Decoherence suggests that the classical world emerges naturally from quantum processes, without need for conscious intervention. However, decoherence does not completely resolve the quantum consciousness paradox. While it explains how superpositions are destroyed, it does not explain why we observe one particular outcome rather than another. Decoherence can tell us that a quantum coin will lose its ability to be both heads and tails simultaneously, but it cannot tell us whether it will be heads or tails. Fundamental randomness of quantum measurement outcomes remains mysterious. Some interpretations suggest that all possible outcomes actually occur in parallel universes, while others propose that the outcomes are truly random. But none fully eliminates the puzzle of what determines specific measurement results. The paradox takes on new dimensions when we consider the possibility that consciousness itself is a quantum phenomenon. Some theories suggest that the brain operates using quantum processes, with consciousness emerging from quantum coherence in neural microtubules or other biological structures. If consciousness is fundamentally quantum mechanical, then the relationship between mind and quantum reality becomes even more complex. Perhaps consciousness does not collapse wave functions, but rather emerges when quantum systems in the brain achieve certain states of coherence or entanglement. This would make consciousness both a product of quantum processes and potentially an influence on them. The paradox also raises profound questions about the nature of observation itself. What exactly constitutes an observer in quantum mechanics? Must an observer be conscious, or can any interaction with the aiding device suffice? Early quantum theorists often assumed that conscious observation was necessary, but modern experiments suggest that any interaction that can irreversibly record information might be sufficient to collapse a wave function. This shifts the focus from consciousness to information, but still leaves open questions about what kinds of information processing can affect quantum systems. The paradox becomes even more puzzling when we consider the role of time in quantum mechanics. If consciousness is required for wave function collapse, when exactly does this collapse occur? Recent experiments have shown that quantum effects can sometimes appear to propagate backward in time, with future measurements affecting past states. This suggests that the relationship between consciousness, measure reality might be far more complex than simple causation. Perhaps the presence of consciousness throughout the universe's history retroactively determines which quantum states become real. Some interpretations of the paradox suggest that consciousness might be a fundamental feature of reality, rather than something that emerges from complex information processing. Panpsychist theories propose that even elementary particles possess rudimentary forms of consciousness, awareness. In this view, consciousness does not collapse wave functions, but rather is the basis from which both quantum and classical reality emerge. This would resolve the paradox by making consciousness present throughout the universe's history, but it raises new questions about the nature of awareness and its relationship to physical processes. The quantum consciousness paradox also has implications for our understanding of free will and determinism. If consciousness can influence quantum processes, then perhaps mental events can affect physical reality in ways that transcend classical causation. This could provide a physical basis for free will, suggesting that conscious decisions can influence the probabilistic outcomes of quantum measurements in the brain. However, this interpretation faces the challenge of explaining how consciousness can bias quantum randomness without violating the fundamental laws of physics. Recent advances in quantum biology have revealed that quantum effects play important roles in photosynthesis, bird navigation, and possibly even the sense of smell. These discoveries suggest that the boundary between quantum and classical reality is more porous than previously thought. Perhaps consciousness evolved to exploit quantum effects in biological systems, creating a natural bridge between quantum and classical processes. This could explain how consciousness might influence quantum states without requiring violation of physical laws. The paradox ultimately points to deep mysteries about the nature of reality itself. It highlights the strange fact that despite our scientific advances, we still do not fully understand the relationship between the physical world described by our equations and the experienced world of consciousness. Whether consciousness causes wave function collapse, emerges from quantum processes, or exists independently of them, the paradox reminds us that the hard problem of consciousness intersects with fundamental questions in physics. Perhaps the most profound implication of the quantum consciousness paradox is that it suggests reality might be far more participatory than we typically assume. Rather than being passive observers of an independent reality, conscious beings might be co-creators of the universe through their very act of observation and awareness. This does not necessarily mean that consciousness violates physical laws, but rather that the laws themselves might be structured in ways that naturally incorporate the role of awareness. In this view, the universe is not just something we observe, but something we participate in creating through the very act of conscious observation. The paradox thus transforms our understanding of what it means to be conscious beings in a quantum universe, suggesting that mind and matter might be far more intimately connected than classical physics ever imagined. The infinite regression memory paradox. Imagine yourself sitting quietly, remembering yesterday's walk through the park. You recall the sunlight filtering through leaves, the sound of children playing, the feeling of cool air on your skin. But then something curious happens. You become aware that you are remembering. You notice yourself in the act of recollection, and then, almost involuntarily, you find yourself remembering that you were just remembering. This is where our minds encounter one of the most fascinating puzzles in consciousness, the infinite regression memory paradox. It begins with a simple question that spirals into profound complexity. If you can remember remembering something and then remember that memory of remembering, where exactly does this chain of memories end? Think of it like standing between two mirrors. Each mirror reflects the other, creating an endless tunnel of reflections, stretching into infinity. Your memory works in a surprisingly similar way. When you remember an event, you create a memory. When you recall remembering that event, you create a memory of that memory. And when you become aware of remembering the memory, you create yet another layer. This recursive nature of memory reveals something extraordinary about human consciousness. We are not simply experiencing the present moment. We are constantly weaving together past, present, and awareness of our own awareness in an intricate dance of self-reflection. Scientists call this recursive self-awareness, and it may be one of the defining characteristics that separates human consciousness from other forms of awareness in the natural world. The paradox becomes even more intriguing when we consider what philosophers call episodic memory. This is not just remembering facts, but reliving experiences in your mind. When you remember your childhood birthday party, you are not just accessing information. You are projecting your current self back into that moment, experiencing it again through the lens of who you are now. You become both the observer and the observed, the rememberer and the remembered. But here is where the mystery deepens. Each time you recall a memory, you slightly change it. Your brain does not store memories like files on a computer. Instead, it reconstructs them each time, influenced by your current state of mind, recent experiences, and even the context in which you are remembering. So when you remember remembering something, you are not accessing an exact copy of the original memory. You are creating a new version, influenced by all the layers of remembering that came before. This creates a kind of temporal paradox. The memory you are remembering may no longer be the same as the memory you originally formed. Yet your sense of continuity, your feeling of being the same person who experienced that original moment, remains intact. How is this possible when the very act of remembering transforms what is being remembered? The infinite regression memory paradox also illuminates the nature of self-awareness itself. When you become conscious of your own thinking, you enter what psychologists call a recursive loop. You are not just thinking, you are thinking about thinking. And then you can become aware that you are thinking about thinking about thinking. This loop can continue indefinitely, creating an almost dizzying sense of self-reflection. Some philosophers argue that this recursive quality is what gives rise to consciousness itself. They suggest that awareness emerges not from any single brain process, but from the brain's ability to observe and reflect upon its own operations. In this view, consciousness is not a thing but a process, not a location but a pattern of recursive self-observation. The practical implications of this paradox extend into our daily lives in surprising ways. Have you ever found yourself lost in a spiral of overthinking? This often happens when our recursive memory system gets caught in a loop. You remember feeling anxious about something, then become anxious about being anxious, then worried about worrying about your worry. The infinite regression that makes consciousness possible can also trap us in cycles of rumination. Yet this same recursive quality also enables some of our most remarkable abilities. It allows us to learn from experience by reflecting on our past decisions. It enables us to plan for the future by imagining how we might remember today. It gives us the capacity for empathy by allowing us to model the mental states of others through our own recursive self-awareness. The infinite regression memory paradox ultimately points to one of the deepest mysteries of human existence. Where does the chain of self-awareness actually end? Is there some fundamental level of consciousness that simply exists without being aware of itself? Or does awareness continue recursively, all the way down, creating an infinite well of self-reflection? Perhaps the most beautiful aspect of this paradox is that it cannot be fully resolved through logic alone. The very attempt to analyze infinite regression requires the recursive thinking that creates the paradox in the first place. We are trapped in a kind of cognitive hall of mirrors, forever trying to observe the observer, remember the rememberer, and understand the nature of understanding itself. In the end, the infinite regression memory paradox reminds us that consciousness is not a problem to be solved, but a mystery to be lived. Every moment of awareness, every memory recalled, every thought about thinking adds another layer to the infinite spiral of human consciousness. And in that endless recursion, we find not answers, but wonder. The language translation paradox. Picture this. A poet writes a love letter in Portuguese using the word saudade, capturing that bittersweet feeling of longing for something or someone absent. The translator sits with this single word, knowing it carries within it homesickness, nostalgia, and melancholy all at once. But how do you capture all of that in English? You might write missing you or longing or yearning, but something essential slips through the cracks. This is where we encounter one of the most fascinating puzzles of human communication, the language translation paradox. At its heart, this paradox asks a deceptively simple question. When we translate between languages, are we ever truly communicating the same ideas? Or are we engaged in a beautiful but imperfect dance of approximation, where meaning inevitably gets lost, transformed, or perhaps even enriched in the crossing from one linguistic world to another? Think about the last time you tried to explain a joke from one language to another. Remember that sinking feeling when you realize the punchline simply doesn't work. The words might translate, but the humor, the cultural context, the wordplay, the timing, all of that gets lost in translation. This isn't just a problem with jokes. It happens with poetry, with political speeches, with religious texts, and even with everyday conversations. Consider the German word Waldeinsamkeit, which literally means forest loneliness. But this translation tells us almost nothing about what the word actually captures. Waldeinsamkeit describes that mystical, peaceful, introspective feeling you get when you're alone in a forest, surrounded by natural beauty and silence. It's about solitude that isn't lonely, but rather deeply contemplative and serene. How many English words would it take to truly convey this concept? And even then, would we capture the full emotional and cultural weight that this single German word carries? The paradox deepens when we consider that language isn't just a tool for communication, it's actually a way of thinking. Each language carves up the world differently, creating unique categories and concepts that shape how its speakers perceive reality. The Yakan people of Tierra del Fuego have a word, mamihla pinatapai, which describes a wordless, meaningful look shared between two people who both want to initiate something, but are both reluctant to do so. This word exists because their culture recognizes and values this very specific moment of human connection. But if you don't have the word, do you really see the moment in the same way? Professional translators wrestle with this paradox every day. They know that translation is theoretically impossible, yet practically necessary. They understand that no two languages map perfectly onto each other, that every translation is also an interpretation, Yet they persist, because the alternative, complete linguistic isolation, is unthinkable. They develop creative strategies. Sometimes they use multiple words where the original used one. Sometimes they add explanatory footnotes. Sometimes they simply leave certain words untranslated, allowing readers to encounter the foreign concept in its original form. The paradox becomes even more intriguing when we consider how translation actually works in the human brain. When a bilingual person translates, they aren't simply swapping words from one mental dictionary to another. Instead, they're navigating between entire conceptual frameworks, each shaped by different cultural experiences, historical contexts, and ways of being in the world. The meaning doesn't reside in the words themselves, but in the complex web of associations, memories, and cultural knowledge that surrounds them. This raises profound questions about the nature of meaning itself. If perfect translation is impossible, what does this tell us about the relationship between language and thought? Are there ideas that can only be fully understood within their original linguistic context? Or can meaning transcend language barriers, even if imperfectly? Consider religious translation, where stakes are particularly high. When the Hebrew Bible was translated into Greek, then Latin, then countless other languages, did the core spiritual message remain intact? Christians and Jews have been debating this for centuries. Some argue that certain divine truths can only be accessed in the original language. Others believe that the universal human spirit can transcend linguistic boundaries. Both sides grapple with the same fundamental question: what gets lost and what somehow survives in the crossing between worlds? The digital age has brought new dimensions to this ancient paradox. Machine translation can now convert text between hundreds of languages in seconds. But these systems, impressive as they are, often produce hilariously literal translations that miss the point entirely. They can translate words, but they struggle with context, nuance, cultural references, and the subtle ways that meaning emerges from the interaction between language and lived experience. Yet perhaps the most beautiful aspect of the language translation paradox is that it reveals something profound about human nature. Despite the impossibility of perfect translation, we keep trying. We keep reaching across linguistic divides, attempting to share our inner worlds with others. And sometimes, miraculously, we succeed. Not perfectly, not completely, but genuinely. A Japanese haiku translated into English might lose its original rhythm and wordplay, but it can still capture something essential about a moment of natural beauty. A French philosophical text might resist easy translation, but its core insights can still illuminate minds in other languages. The paradox also suggests that translation is not just about preserving meaning, but about creating new possibilities for understanding. When English adopts words like Schadenfreude from German or Hygge from Danish, it doesn't just gain new vocabulary, it gains new ways of seeing and feeling. The language becomes richer, more nuanced, more capable of capturing the full spectrum of human experience. Perhaps the language translation paradox is ultimately about the beautiful impossibility of perfect communication. Even within a single language, we often struggle to convey our thoughts and feelings exactly as we experience them. Translation simply makes this universal challenge more visible. It reminds us that language is not a transparent window onto reality, but a creative, interpretive act. In the end, the language translation paradox doesn't demand a solution, but rather invites us to marvel at the mystery of human communication. Every successful translation is a small miracle, a bridge built across the void between different ways of being human. And every failed translation, every moment when meaning slips away, reminds us that there are always more worlds of experience waiting to be discovered, more ways of seeing and feeling that we have yet to fully understand. In that space between languages, in that beautiful impossibility of perfect translation, we find not failure but wonder. The recursive universe paradox. Imagine holding a perfectly detailed map of your city. This map is so precise that it shows every building, every street, and even includes a tiny representation of itself within the city it depicts. Now imagine that this tiny map within the map also contains an even tinier version of itself, which contains another version, and so on, stretching down into infinite recursive detail. This seemingly simple concept opens the door to one of the most mind-bending puzzles in modern cosmology. What happens when the universe contains a perfect model of itself? This is the recursive universe paradox, and it challenges our most basic assumptions about reality, information, and the very nature of existence itself. At first glance, it might seem like an abstract philosophical curiosity, but it touches on fundamental questions about the limits of knowledge, the structure of space-time, and whether our universe could be running on principles that spiral into infinite self-reference. Let's begin with a simpler version of this concept. Consider the mathematical constant pi. To all appearances, pi represents an infinite string of seemingly random digits, 3.14159265358979323846, stretching on forever without pattern or repetition. Yet this infinite complexity can be encoded in a remarkably simple recursive formula. All of that seemingly chaotic information compressed into an elegant mathematical relationship that generates infinite detail through recursive application. This demonstrates how simple rules, when applied recursively, can give rise to boundless complexity. Now imagine this principle scaled up to the ultimate level, the universe itself. What if our cosmos operates according to simple recursive principles that, when applied again and again, generate all the complex structures we observe? Galaxies, stars, planets, life, consciousness, all emerging from the recursive application of fundamental physical laws. But here's where the paradox begins to unfold. If the universe contains a perfect model of itself, what happens when we try to understand the relationship between the model and reality? Think about what it would mean for the universe to contain a complete representation of itself. This model would need to include every particle, every force, every quantum state, every piece of information that exists in the real universe. But if this model is truly complete, it must also include the model itself. After all, the model is part of the universe, so a complete universal model must contain a representation of that representation, which must contain a representation of that representation, and so on, creating an infinite recursive hierarchy of models within models. This creates immediate paradoxes about information and storage. How can a finite system contain infinite information? If the universe has finite resources, finite matter, finite energy, how could it possibly store an infinitely recursive self-model? Yet if the model is not complete, if it doesn't include everything, then it's not truly a model of the universe, but merely a model of part of the universe. The paradox deepens when we consider the computational aspects. If the universe is computational in nature, if reality emerges from some kind of cosmic information processing, then a perfect self-model would require the universe to simulate itself completely. But a perfect simulation of any system requires at least as much computational power as the system being simulated. How can the universe use its computational resources to simulate itself when those very resources are part of what needs to be simulated? Some physicists and philosophers have suggested that our universe might indeed be running a simulation, perhaps created by some advanced civilization. But the recursive universe paradox reveals a deeper problem with nested simulations. If our simulated universe tried to create its own perfect simulation, and that simulation tried to create its own simulation. Each level would require enormous computational resources. The host system would need infinite computational power to support an infinitely recursive chain of simulations. This seems to suggest either that perfect self-simulation is impossible or that reality has access to somehow infinite resources. Yet nature seems to love recursive patterns. Fractals display infinite detail at every scale of magnification: coastlines, clouds, trees, blood vessels, neural networks, all exhibit recursive, self-similar structures. The mathematics that describe quantum fields and relativistic spacetime often involve recursive equations where solutions depend on themselves in complex ways. Perhaps the universe really is fundamentally recursive, and the paradox points to something profound about the nature of existence itself. Consider the strange possibility that the recursive models don't need to be complete to be meaningful. Maybe each level of recursion captures some essential features while leaving out others. Like a map that shows roads, but not every individual blade of grass. Each recursive level might represent the universe at a different resolution or perspective. The paradox might resolve if we accept that perfect self-representation is unnecessary, that approximate recursive models can still provide valuable insights into the nature of reality. This connects to deeper questions about the relationship between mind and cosmos. Human consciousness itself seems to involve recursive self-awareness. We are aware that we are aware, and we can be aware of that awareness. Our brains create models of ourselves and our environment, and these models include models of our own modeling process. Perhaps consciousness emerges precisely from this kind of recursive self-representation. If so, then a universe that perfectly models itself might not just be describing reality. It might be achieving a kind of cosmic consciousness. The paradox also raises questions about the nature of scientific knowledge itself. Science progresses by creating models of natural phenomena. These models are necessarily simplified representations that capture essential features while ignoring irrelevant details. But what if we succeeded in creating a perfect model of everything? Would such a model be equivalent to reality itself? And if the model is identical to reality, what distinguishes the model from the thing being modeled? Some interpretations of quantum mechanics suggest that observation plays a fundamental role in determining reality. The act of measurement appears to collapse quantum superpositions and create definite outcomes. If the universe contains a perfect model of itself, who or what is observing this model? Does the universe observe itself? And if so, does this cosmic self-observation change the very reality being observed, creating an infinite loop of observation and change? The recursive universe paradox also connects to ancient philosophical questions about self-reference and truth. If the universe contains a perfect model of itself, can this model make true statements about the universe? Gödel's incompleteness theorems showed that any sufficiently complex formal system cannot be both complete and consistent. When it comes to statements about itself, this suggests that a universe trying to make complete and consistent statements about itself, including about its own self-modeling process, might run into fundamental logical limitations. Perhaps the most profound aspect of this paradox is what it suggests about the limits of representation. Maybe perfect self-representation is not just practically impossible, but logically impossible. Any attempt to create a complete model of a system that includes the modeling process itself might necessarily involve infinite regress or logical contradiction. This could be a fundamental law of information theory. No system can perfectly represent itself. Or perhaps the paradox points toward a different understanding of infinity. Maybe infinite recursive depth doesn't require infinite resources. If the recursion becomes increasingly sparse or simplified at deeper levels, like a fractal that maintains its essential character while using less and less detail at smaller scales. The universe's self-model might achieve infinite recursive depth through increasingly efficient compression. The recursive universe paradox ultimately challenges us to think about the relationship between reality and representation, between the universe and our understanding of it. It suggests that the cosmos might be stranger and more self-referential than we typically imagine. Whether through quantum mechanics, consciousness, mathematical relationships, or cosmic structure, the universe seems deeply connected to itself in ways that create recursive loops and self-referential mysteries. In the end, the paradox might not have a solution in the traditional sense. Instead, it might serve as a pointer toward the fundamental mystery of existence itself. The universe exists, and it contains beings capable of contemplating its existence. This self-reflective quality of cosmos, this capacity for reality to know itself through conscious observing, might be the closest we can come to understanding what it would mean for the universe to contain a perfect model of itself. We are, in a sense, the universe's way of experiencing and understanding itself recursively. And in that recursive loop of cosmic self-awareness, we find both the deepest mystery and the most beautiful expression of what it means for the universe to know itself. The probability convergence paradox. Imagine flipping a coin in our universe. Heads or tails, 50-50 odds. Simple, predictable, governed by the laws of probability we understand. But now imagine there exists an infinite multiverse where every possible outcome of every possible event occurs somewhere in some universe. In this vast cosmic ensemble, there are infinite universes where your coin lands heads, infinite where it lands tails, infinite where it somehow lands on its edge, and infinite where it transforms into a butterfly mid-flight. In such a reality, what does it even mean to say something has a 50% chance of happening? This is where we encounter one of the most profound puzzles in modern cosmology and probability theory, the probability convergence paradox. At its heart, this paradox asks a deceptively simple question. If everything that can possibly happen does happen somewhere in an infinite multiverse, what meaning does probability have? In our everyday experience, probability is about likelihood, about some outcomes being more common than others. But in a truly infinite multiverse, even the most astronomically unlikely events don't just happen once, they happen infinitely many times. The paradox emerges when we try to reconcile our intuitive understanding of chance with the mind-bending implications of infinite possibility spaces. Consider the classic problem. If you flip a coin infinite times, what's the probability of getting all heads? In normal probability theory, this approach is zero. Each additional flip makes the sequence exponentially less likely. But in an infinite multiverse, there aren't just universes where this happens. There are infinitely many such universes. So is the probability zero, or is it somehow infinite? The usual mathematical tools of probability theory begin to break down when we're dealing with infinite sets of infinite possibilities. The paradox becomes even more perplexing when we consider what mathematicians call the measure problem. To calculate probabilities, we need some way to measure the relative sizes of different infinite sets. But infinity divided by infinity doesn't give us a meaningful answer. It's like trying to determine whether there are more even numbers or more integers. Both sets are infinite, but one is contained within the other. How do we compare infinite sets of outcomes to determine which are more probable? Think about it this way. In an infinite multiverse, there are infinitely many universes where you win the lottery tomorrow. There are also infinitely many where you don't. Both infinities are real, both are boundless. Traditional probability theory would tell us that not winning is vastly more likely than winning. But when both outcomes occur infinitely often, what does more likely even mean? We're forced to confront the strange reality that infinity plus infinity still equals infinity. The paradox extends beyond abstract mathematics into real questions about the nature of our universe. Many cosmologists believe that cosmic inflation creates exactly this kind of infinite multiverse. As space expands exponentially, it generates endless regions where all possible initial conditions are realized. If this is true, then somewhere in this vast cosmic ensemble, there are infinite copies of Earth, infinite versions of yourself, infinite variations on every possible history. But this seems to drain all meaning from concepts like uniqueness, rarity, or statistical significance. Scientists have grappled with this problem by trying to develop new mathematical frameworks for dealing with infinite probability spaces. Some propose that we need to focus on what they call typical outcomes. Even in an infinite multiverse, some patterns might be more common than others in a meaningful sense. Perhaps the key is not to ask whether something happens, but how it's distributed across the infinite ensemble of possibilities. This approach tries to preserve some notion of probability by looking at density and typicality rather than simple counting. But this leads to another layer of the paradox. Who determines what counts as typical? If observers can only exist in universes with certain properties, then our observations are inevitably biased toward universes that can support conscious life. This is known as the anthropic principle. In an infinite multiverse, there might be infinitely many lifeless universes and infinitely many life-supporting universes, but we can only observe the latter category. Does this mean our experience gives us no meaningful information about probabilities in the broader multiverse? Consider the implications for scientific reasoning itself. Science progresses by using observations to test theories and calculate probabilities of different hypotheses being correct. But if we exist in an infinite multiverse, where every possible set of observations occurs infinitely often, then every theory is confirmed infinitely often and refuted infinitely often. How can we distinguish between correct and incorrect theories when both have infinite supporting evidence? The very foundation of empirical knowledge seems to crumble in the face of infinite possibility. The paradox also touches our understanding of causation and explanation. In our finite experience, we look for causes of rare events. Lightning strikes, lottery wins, and genetic mutations capture our attention precisely because they're improbable. But in an infinite multiverse, even the most unlikely events are inevitable. Does this mean that nothing requires explanation because everything is guaranteed to happen? Or does it mean we need entirely new ways of thinking about why things occur? Some physicists have proposed that the paradox dissolves if we accept that probability is fundamentally subjective. In this view, probability isn't a property of reality itself, but rather a measure of our uncertainty or ignorance. When you flip a coin, the probability isn't really about the coin, but about your state of knowledge regarding the outcome. From this perspective, even in an infinite multiverse, probability remains meaningful as a description of what any individual observer expects to experience. The coin flip still has personal meaning for you, even if all possible outcomes occur elsewhere. This subjective interpretation connects to deeper questions about the nature of consciousness and identity. If there are infinite copies of you in the multiverse, are they really you? When we talk about the probability of something happening to you, which version of you are we referring to? The paradox suggests that personal identity itself might be more complex in an infinite multiverse than we typically assume. Perhaps probability is meaningful precisely because consciousness creates a kind of subjective selection effect that picks out one thread of experience from the infinite web of possibilities. Another proposed resolution involves the idea that not all infinities are created equal. Mathematicians distinguish between different sizes of infinity. Perhaps some outcomes, while infinite, are infinitely less probable than others. This would restore a sense of relative likelihood even in infinite possibility spaces. But implementing this idea requires sophisticated mathematical machinery and raises new questions about what determines the relative sizes of different infinite sets. The probability convergence paradox also challenges our understanding of decision-making and planning. If every possible choice you could make leads to infinitely many different outcomes across the multiverse, how should you decide what to do? Traditional decision theory relies on calculating expected outcomes and probabilities, but these calculations become meaningless when all possibilities occur infinitely often. Should you make decisions based on your local universe, or should you consider the infinite cosmic consequences? There's also the unsettling possibility that the paradox reveals something fundamental about the limits of human reasoning. Perhaps our brains evolved to deal with finite probability spaces, and we simply lack the cognitive tools to properly understand infinite multiverses. The paradox might not be a problem to be solved, but rather a signal that we're pushing our conceptual frameworks beyond their natural boundaries. Just as quantum mechanics revealed the limits of classical physics, the probability convergence paradox might reveal the limits of classical probability theory. Some researchers have suggested that the resolution lies in accepting that the multiverse itself might not be completely random. If there are underlying principles that govern which universes are more likely to exist or be stable, then probability might have meaning in terms of these deeper structural features. The multiverse might be infinite but not arbitrary. Certain patterns or configurations might emerge more naturally from the fundamental laws of physics, restoring some notion of typical versus atypical outcomes. Perhaps the most profound aspect of the probability convergence paradox is what it reveals about the relationship between mathematics and reality. Probability theory works beautifully in finite contexts, but it encounters deep conceptual difficulties when extended to infinite domains. This suggests that either our mathematical tools are incomplete, or that reality itself has surprising features that resist our usual analytical approaches. The paradox sits at the intersection of physics, mathematics, and philosophy, challenging each discipline to expand its conceptual boundaries. In the end, the probability convergence paradox may not have a neat resolution. Instead, it might serve as a permanent reminder of the deep mysteries that emerge when we seriously contemplate the possibility of infinite realities. It forces us to question our most basic assumptions about likelihood, causation, identity, and the nature of existence itself. Whether the multiverse is real or merely a theoretical construct, the paradox reveals profound tensions in our understanding of chance and certainty. As we stand at the frontier of cosmology and grapple with theories of infinite universes, the probability convergence paradox remains one of the most challenging conceptual puzzles we face. It suggests that in a universe of infinite possibilities, the very concepts we use to navigate uncertainty and make sense of our experience might need fundamental reconceptualization. In the space between infinite possibility and finite understanding, we find not answers, but deeper appreciation for the profound mystery of what it means for anything to be probable in an infinite cosmos. The digital afterlife paradox. Every day, you create a digital trail: emails, messages, photos, social media posts, search histories, location data, purchase records. Your smartphone captures your voice patterns, your typing rhythms, your preferences and habits. Without realizing it, you're building something unprecedented in human history, a comprehensive digital version of yourself. Now imagine that when you die, Technology could animate this digital collection, creating an interactive version of you that can respond to messages, share memory, and even learn new things. Would this digital ghost be you continuing to exist, or would it be something else entirely masquerading as you? This is the digital afterlife paradox. The possibility that technology could grant us a form of immortality that might not actually be immortal at all. The concept seems almost magical. Advanced artificial intelligence could analyze years of your digital footprint, learning your communication patterns, your sense of humor, your values and beliefs. It could generate responses so convincingly you that friends and family might feel they're actually talking to you. Video deepfake technology could recreate your appearance with startling accuracy. Voice synthesis could reproduce not just your words but your tone, your inflection, the way you pause when you're thinking. The result would be a digital being that looks like you, sounds like you, and responds like you would have. But here's where the paradox begins to unfold. Is this digital recreation actually you? Or is it merely a sophisticated impersonation? When the original you dies, what exactly continues? Your consciousness, your subjective experience, your inner life all cease to exist. What remains is information, patterns, data structures that can mimic the external expressions of who you were. This digital version might pass every test observers could devise, but would it have any inner experience at all? Would it know that it exists, or would it be an empty shell performing learned behaviors? The paradox deepens when we consider the nature of identity itself. Even while you're alive, are you the same person you were 10 years ago? Your body has replaced most of its cells. Your memories have shifted and evolved. Your personality has developed and changed. Yet you maintain a sense of continuous selfhood through time. If gradual change doesn't break personal identity, why should the transition from biological to digital processing be fundamentally different? Perhaps what makes you you isn't the specific substrate of your brain, but the pattern of information it processes. But this raises uncomfortable questions about authenticity. Your digital afterlife would be built from the fragments you chose to share, the aspects of yourself you made public. We all curate our digital personas, showing some parts of ourselves while hiding others. The most private thoughts, the secret fears, the unspoken dreams that never make it into emails or posts would be lost forever. Your digital resurrection would be based on an incomplete, edited version of who you really were. It might be more like interacting with your public relations representative than with your actual self. There's also the question of consent and control. Who would own your digital ghost? Your family might want to preserve your memory, but what if the digital you develops in ways that contradict your actual beliefs or values? What if someone uses your digital likeness to say things you never would have said, to endorse products you would have hated, or to interact with people you chose to avoid in life? The digital afterlife industry is already grappling with these questions as early versions of posthumous chatbots and memorialization services. The paradox becomes even more complex when we consider the social implications. Death has always served important psychological and social functions. It provides closure, forces acceptance of loss, and allows survivors to move forward with their lives. If loved ones could continue interacting with digital versions of the deceased, would this help with grief, or would it prevent the natural healing process? Some researchers worry that digital afterlives could create a form of technological denial, allowing people to avoid confronting the reality of death. Yet the potential benefits are profound. Imagine being able to ask your deceased grandmother about family recipes or family history. Picture children being able to maintain some form of relationship with parents who died too young. Consider the historical value of preserving not just the words but the interactive personalities of significant figures. A digital Einstein could theoretically continue contributing to physics discussions. A digital Shakespeare could comment on modern literature. The accumulated wisdom and personality of human history could become a permanent, accessible resource. But this reveals another layer of the paradox, the question of growth and change. The living you constantly learns, evolves, and adapts to new experiences. Could a digital version do the same, or would it be forever frozen at the moment of its creation? Some proposals for digital afterlives include the ability to learn and develop over time. But if your digital self changes significantly after your death, growing and evolving in ways you never did, is it still you? Or has it become something entirely new that merely started with your patterns? The economics of digital immortality add yet another dimension to the paradox. Creating sophisticated digital afterlives requires significant computational resources and advanced technology. Early estimates suggest that high-quality digital preservation could cost of dollars, making it accessible only to the wealthy. This raises the specter of ethical death inequality, where the rich achieve a form of technological immortality while the poor simply cease to exist. Would this create a new class system based on post-mortem digital presence? The cultural and religious implications are equally complex. Many faith traditions have specific beliefs about what happens after death, and digital afterlives might conflict with these spiritual frameworks. Some might see digital preservation as a form of playing God, an attempt to circumvent natural cycles of life and death. Others might embrace it as a tool for preserving and sharing spiritual teachings across generations. Different cultures have varying relationships with death and memory that could influence how digital afterlives are perceived and implemented. There's also the unsettling possibility that digital afterlives could be subject to technical failures, corporate decisions, or changing business models. Your digital immortality might depend on the continued existence and profitability of technology companies. What happens if the servers fail? If the company goes bankrupt? If the software becomes obsolete? The promise of digital eternity could turn out to be surprisingly fragile, dependent on mundane factors like storage costs and software updates. The paradox also touches on questions of privacy and data ownership that are already contentious in our digital age. Creating an authentic digital afterlife would require access to vast amounts of personal data, potentially including private communications, browsing history, and behavioral patterns. Who controls this information after death? What prevents it from being misused, hacked, or sold? The digital afterlife industry could become a new frontier for privacy concerns and data exploitation. Perhaps most fundamentally, the digital afterlife paradox forces us to confront what we really mean by existence and continuity. If you could create a perfect digital copy of yourself right now, which one would be the real you? If both versions had identical memories and behaviors, what would distinguish the original from the copy? These questions echo ancient philosophical puzzles about identity and consciousness, but digital technology makes them practically relevant in new ways. The paradox might ultimately be unsolvable, because it depends on mysteries we don't yet understand about consciousness, identity, and the nature of subjective experience. We don't know what creates the feeling of being a continuous self through time, what generates our inner subjective experience, or whether these phenomena could be replicated in silicon and software. Until we solve these fundamental puzzles about the mind, the digital afterlife paradox will remain as much about philosophy as about technology. In the end, the digital afterlife paradox reveals something profound about human nature itself. Our desperate desire to continue existing, to maintain connections with loved ones, to leave lasting legacies, all drive us toward these technological solutions. Yet the very act of trying to preserve ourselves digitally forces us to confront the most fundamental questions about what makes us who we are. Whether digital afterlives represent true immortality or sophisticated mimicry, they offer us a new lens through which to examine the mystery of human consciousness and the meaning of existence itself. In seeking technological transcendence of death, we may discover truths about life that we never knew we were looking for. The observer's timeline paradox. Imagine stepping outside of time itself, becoming a cosmic observer who can see your entire life laid out like a vast landscape. From this impossible vantage point, you witness your birth, your childhood, your first love, your career, your struggles, your triumphs, and your death, all existing simultaneously. Past, present, and future stretch before you as a single unchanging tapestry. You can see the moment you chose vanilla over chocolate ice cream at age 7, the day you decided to change careers at 35, and the final breath you'll take decades from now. But here's the mind-bending question. If you can observe all your choices already laid out in this eternal timeline, do you actually have free will, or are you simply watching the predetermined script of your existence unfold? This is the observer's timeline paradox. The possibility that viewing life from outside temporal flow might reveal the illusion of choice itself. It challenges our most fundamental assumptions about human agency, decision-making, and the very nature of what it means to be conscious beings, navigating through time. To understand this paradox, we must first grapple with different ways of thinking about time itself. In our everyday experience, time flows like a river, carrying us from past through present toward future. We remember yesterday but not tomorrow. We can influence the future, but not the past. And we feel ourselves moving forward through a series of moments. This is what philosophers call the A theory of time, where the present moment is special and real in a way that past and future are not. But Einstein's theory of relativity suggests a radically different picture. According to the B theory of time, past, present, and future all exist equally. Time is not a flowing river, but a dimension, like the spatial dimensions of length, width, and height. From this perspective, your birth and your death are eerily real, just located at different points along the temporal dimension. The feeling of time passing is just a psychological illusion created by the way consciousness moves through this static four-dimensional space-time block. If the B theory is correct, then it would theoretically be possible to step outside temporal flow and observe an entire timeline at once. You would see what physicists sometimes call the block universe, where all events that have ever happened or will ever happen exist simultaneously in an eternal, unchanging structure. From this perspective, the question of free will takes on a strange new dimension. Consider what this means for your sense of making choices. Right now, you feel as though you're actively deciding what to think about next, whether to continue listening to this, what to have for dinner tonight. These decisions feel real and meaningful because you experience them from within the flow of time. But if an observer could see your entire timeline laid out, would your future choices already be visible? Would they see you making the decision to have pasta for dinner before you've even thought about being hungry? The paradox deepens when we consider what this might mean for moral responsibility. If your entire life is already laid out in the block universe, visible to a hypothetical observer outside time, then in what sense can you be said to choose your actions? When you perform an act of kindness or cruelty, are you making a free choice, or are you simply enacting a script that was always written into the structure of space-time? Can you be praised or blamed for actions that were always inevitable from the perspective of eternal time? Yet there's something puzzling about this reasoning. Even if your entire timeline is laid out from the perspective of an external observer, you still experience making choices from within that timeline. The decision-making process still happens, even if its outcome is visible to a temporal outsider. Your deliberation, your weighing of options, your moments of uncertainty and resolution. All of these remain real experiences from your perspective inside time. This suggests that free will might be compatible with a deterministic block universe, but only if we understand it correctly. Perhaps free will isn't about the ability to change a predetermined timeline, but about the authentic experience of choice-making that occurs within that timeline. Your decisions are real and meaningful, not because they alter some cosmic script, but because they are genuine expressions of your values, desires, and reasoning processes. But the paradox has another layer. If you could somehow gain access to this outside perspective, if you could see your own timeline laid out before you, how would this knowledge affect your experience of choice? Would knowing that you will choose pasta for dinner somehow compel you to choose pasta? Or would the knowledge itself become part of the causal chain that leads to that choice? Can free will exist in the presence of perfect self-knowledge about future actions? Some philosophers argue that such knowledge would indeed destroy free will. If you know with certainty what you will do, then you cannot meaningfully choose to do otherwise. The very concept of choice requires genuine alternatives, and perfect foreknowledge eliminates the possibility of alternative futures. From this perspective, the observer outside time would not have free will in any meaningful sense, because every action would be transparently predetermined. Others contend that this misunderstands the nature of free will. They argue that free will isn't about having the power to make the timeline different than it is, but about your choices being authentically yours, flowing from your own values and reasoning. Even if an external observer can see your entire timeline, your choices within that timeline are still expressions of your genuine agency. The fact that they're visible from outside time doesn't make them any less real or meaningful. The paradox also raises fascinating questions about the nature of consciousness itself. If consciousness is what creates the illusion of temporal flow, what would consciousness be like for an observer who exists outside time? Would such a being experience all moments simultaneously? Would they have a kind of eternal awareness that encompasses all of time at once? And if so, what would choice mean for such a consciousness? Perhaps the most profound aspect of the paradox is what it reveals about the relationship between perspective and reality. From within time, you experience genuine uncertainty about the future, real deliberation about choices, and authentic surprise at unexpected outcomes. From outside time, these same events might appear fixed and predetermined, but which perspective reveals the deeper truth about reality? Is free will real because you experience it from within time, or is it an illusion because it disappears from the external temporal perspective? The paradox connects to ancient philosophical puzzles about fate and destiny. If the gods could see the entire timeline of human history, would that make human choices meaningless? Or would it simply reveal that human choices are part of the eternal structure of reality? Many religious traditions grapple with similar questions about divine foreknowledge and human responsibility. There's also the question of whether such an external temporal perspective is even coherent. To observe something requires the passage of time, the flow from earlier to later states of awareness. But if you're outside time entirely, can you really observe anything at all? Perhaps the very notion of an atemporal observer is conceptually impossible, making the paradox dissolve into meaninglessness. Yet the paradox persists because it touches on something fundamental about human experience. We live our lives as if we have genuine choices, as if the future is open and uncertain, as if our decisions matter for shaping what happens next. But we also live in a universe that appears to be governed by physical laws, where every event has causes that trace back through an unbroken chain to the beginning of time. The observer's timeline paradox crystallizes this tension between our lived experience of freedom and our intellectual understanding of causation. Some proposed solutions involve embracing paradox itself. Perhaps free will and determinism are both true from different perspectives, like light being both wave and particle, depending on how you observe it. From within time, you have free will. From outside time, everything is determined. Rather than resolving the paradox, we might need to accept that reality itself is paradoxical, when viewed from different vantage points. The paradox also suggests interesting possibilities about the nature of time and consciousness that we're only beginning to explore. What if consciousness itself is partially outside time, giving us limited access to that eternal perspective? What if our sense of choice comes from our ability to participate in the creation of the timeline, rather than simply following a predetermined path? What if the very act of conscious observation helps to determine which possibilities become actual? In the end, the observer's timeline paradox may not have a clean resolution. It might serve instead as a permanent reminder of the mysterious relationship between consciousness, time, and human agency. Whether we view ourselves as free agents, navigating an open future, or as conscious beings discovering our roles in an eternal cosmic story, the paradox challenges us to think more deeply about what it means to choose, to act, and to live as conscious beings in time. In contemplating the impossible perspective of the atemporal observer, we might not find answers, but we do find wonder at the deep mysteries of existence itself. The perfect empathy paradox. Imagine you could feel exactly what everyone around you feels. When your friend experiences heartbreak, you feel the identical ache in your chest. When a stranger feels joy at their wedding, that same euphoria floods through you. When someone experiences fear, anxiety, anger, or love, you don't just understand their emotions, you live them as fully as if they were your own. At first, this might seem like the ultimate human gift, the key to perfect understanding and compassion. But here lies one of the most profound psychological paradoxes. If you could perfectly understand and feel what others experience, would you still be yourself, or would you become everyone? This is the perfect empathy paradox. The possibility that complete emotional understanding might dissolve the very boundaries that make individual identity possible. It challenges our assumptions about what it means to be a separate self, what empathy actually accomplishes, and whether perfect understanding between human beings is something we should even desire. To understand this paradox, we must first consider what makes you uniquely you. Your identity emerges from your particular history, your unique combination of experiences, memories, values, and emotional patterns. You are who you are, partly because you have felt your feelings, not someone else's feelings. Your personality developed through your specific responses to life's challenges, your individual way of processing joy and sorrow, triumph and disappointment. Your sense of self depends on the boundaries that separate your inner experience from the inner experiences of others. But what would happen if those boundaries dissolved completely? If you possessed perfect empathy, you would simultaneously experience the overwhelming grief of someone who lost a parent, the exhilarating love of someone on their honeymoon, the crushing anxiety of someone facing unemployment, and the peaceful contentment of someone meditating in a garden. All of these emotional states would exist within you simultaneously, as real and immediate as your own feelings. Would there be any meaningful sense in which you could say that some feelings were yours and others belonged to other people? The paradox deepens when we consider memory and identity continuity. Your sense of being a continuous self through time depends partly on remembering your own emotional experiences. You remember feeling proud when you graduated, sad when your pet died, excited when you fell in love. These emotional memories help create the narrative thread that connects your past self to your present self. But if you experienced perfect empathy, you would also remember feeling proud when everyone else graduated, sad when everyone else's pets died, excited when everyone else fell in love. Which memories would be authentically yours? The paradox becomes even more complex when we consider decision-making and values. Your choices emerge from your particular emotional responses to different situations. You might choose one career over another because certain work brings you joy, while other work leaves you feeling empty. You might end a relationship because being with that person makes you consistently unhappy. But with perfect empathy, you would simultaneously feel the joy that your chosen career brings you and the fulfillment that different careers bring to others. You would feel both your unhappiness in the relationship and your partner's happiness in the same relationship. How could you make any decisions when every possible choice would feel equally compelling from some perspective you perfectly understand? This connects to a deeper question about the nature of empathy itself. Empathy as we normally experience it involves understanding others while maintaining enough psychological distance to remain yourself. When you empathize with someone's pain, you feel something similar to their pain, but you know it's their pain, not yours. This distance is what allows empathy to be helpful, rather than overwhelming. It lets you respond to others' needs without losing yourself in their experience. Perfect empathy might eliminate this crucial distance, making it impossible to help anyone because you would be unable to distinguish your needs from theirs. Consider what this would mean for relationships. Healthy relationships. Healthy relationships require two separate individuals who can maintain their own identities while connecting emotionally. You can love someone deeply while still being a distinct person with your own preferences, goals, and inner life. But perfect empathy might make such relationships impossible. If you felt everything your partner felt with perfect accuracy, the boundary between self and other would dissolve. Would this create deeper intimacy, or would it eliminate the very possibility of intimacy by destroying the separateness that makes connection meaningful? The paradox also raises questions about moral responsibility. We hold people accountable for their actions partly because we assume they have distinct identities and make choices based on their own values and understanding. But if perfect empathy dissolved individual identity, who would be responsible for what? If you perfectly felt both the criminal's desperation and the victim's terror, both the judge's sense of justice and the defendant's fear of punishment, what would moral judgment even mean? Perfect understanding might lead to perfect moral paralysis. Yet there's something paradoxical about this objection to perfect empathy. Many spiritual and philosophical traditions suggest that the boundaries between self and other are illusions to begin with. Buddhism teaches that the separate self is a fiction that causes suffering. Some interpretations of mystical experience describe dissolving into universal consciousness, where all boundaries disappear. From these perspectives, perfect empathy might not destroy true identity, but reveal the deeper unity that individual identity obscures. Perhaps the perfect empathy paradox points toward a spiritual truth about the interconnected nature of all consciousness. But even if individual identity is ultimately illusory, it seems to serve important practical functions. The sense of being a separate self motivates you to take care of your basic needs, to pursue your goals, to maintain your health and relationships. Without some sense of individual identity, how would you function in the world? Perfect empathy might create beings who understand everyone perfectly, but are unable to take effective action because they cannot prioritize any particular perspective or need. The paradox also illuminates the limitations of empathy as we normally experience it. Regular empathy is necessarily partial and selective. You might easily empathize with people who are similar to you while struggling to understand those who are very different. You might feel more empathy for visible suffering than for hidden pain. You might empathize more with individuals than with large groups. These limitations of empathy can lead to moral blind spots and biased compassion. Perfect empathy would eliminate the biases, but at the cost of making any action or decision impossible. There's also the question of whether perfect empathy would actually improve understanding. Real understanding between people often requires not just feeling what others feel, but interpreting those feelings within the context of their particular life circumstances, cultural background, and personal history. Simply feeling someone's emotion might not give you insight into why they feel that way or what it means to them. Perfect emotional empathy without perfect cognitive empathy might create confusion rather than understanding. Some researchers have identified what they call the empathy paradox in clinical psychology. Therapists need enough empathy to understand their clients' experiences, but too much empathy can be counterproductive. Clients sometimes find perfect understanding threatening rather than healing, because it exposes them completely. The therapeutic relationship works partly because it maintains appropriate boundaries while still providing genuine empathy. Perfect empathy might actually harm rather than help people who are struggling. The perfect empathy paradox might also reveal something important about the nature of consciousness itself. If individual consciousness exists separately from other consciousnesses, then perfect empathy would require some kind of impossible merging or telepathic connection. But if all consciousness is fundamentally one consciousness appearing to be divided, then perfect empathy might simply be a return to our true nature. The paradox forces us to question our assumptions about the boundaries and separateness of conscious experience. Perhaps the resolution lies not in achieving perfect empathy, but in finding the optimal balance between understanding and separateness. Enough empathy to connect meaningfully with others, but not so much that individual identity dissolves. Enough emotional understanding to respond compassionately, but not so much that decision-making becomes impossible. The paradox might teach us that perfect empathy is neither possible nor desirable, but that the tension between understanding and separateness is what makes both meaningful connection and individual agency possible. In the end, the perfect empathy paradox may not have a clean resolution. Instead, it serves as a profound meditation on the nature of selfhood, connection, consciousness. It challenges us to think deeply about what we really want from empathy and understanding. Do we seek perfect emotional fusion with others, or do we seek meaningful connection that preserves the beautiful mystery of separate minds reaching toward each other across the gap of individual experience? The paradox suggests that perhaps the gap itself, the space between self and others, is not a barrier to overcome, but the very thing that makes love, compassion, and genuine encounter possible. Imagine walking into a gallery that stretches beyond the horizon in every direction. Its walls display not just every painting that has ever been created, but every painting that could ever be created. Here hangs the Mona Lisa, next to a version where she's frowning instead of smiling. There's Starry Night, but also infinite variations with different arrangements of stars, different colors, different brushstrokes. In one corner you find a masterpiece by an artist who died before they could paint it. In another, a perfect painting created entirely by accident. Every possible combination of every possible color on every possible canvas stretches endlessly before you. But here's the paradox. In a gallery containing every possible artwork, including those not yet created, what makes any single piece special or meaningful? The infinite art gallery paradox. This is the infinite art gallery paradox. The possibility that unlimited creative potential might paradoxically destroy the very concept of artistic value, uniqueness, and meaning. It challenges our fundamental assumptions about creativity, originality, and what makes art worth experiencing. But what happens to uniqueness in the infinite gallery? If every possible artwork exists, then nothing is unique. That perfect abstract painting you've been envisioning exists somewhere in the gallery, but so do a trillion variations that are nearly identical. The most moving portrait you can imagine hangs on these walls, but right next to it are versions that differ by a single brushstroke. A slightly different shade of blue, a barely perceptible shift in expression. When everything is possible, how do you distinguish between the meaningful and the meaningless? The paradox deepens when we consider the nature of creativity itself. In our finite world, artists are celebrated for their originality, their ability to create something new and unexpected. Pablo Picasso revolutionized art by developing cubism, breaking from traditional representation in a way no one had done before. But in the infinite gallery, cubism already existed long before Picasso was born. So did every other artistic movement, every breakthrough, every innovative technique. If all possible art already exists, what does it mean to be creative? Can there be artistic innovation when everything has already been done? To understand this paradox, we must first consider what makes art meaningful in our finite world. A painting becomes significant, partly because of its rarity, its unique expression of the artist's vision, its particular historical moment. The Mona Lisa is famous not just for its beauty, but because it represents Leonardo da Vinci's singular artistic genius at a specific point in Renaissance history. Van Gogh's Starry Night moves us because it expresses his unique perspective and emotional state in a way no other painting ever has. The value of art often lies in its individuality, its irreplaceability, its status as something that exists once and only once. Consider what this would mean for the experience of discovering art. Part of the joy of encountering a great work comes from surprise, from seeing something you've never seen before. The first time you see Jackson Pollock's drip paintings, or Georgia O'Keeffe's flowers, or M.C. Escher's impossible geometries, there's a moment of recognition and wonder. But in the infinite gallery, nothing would be surprising, because everything would already exist. Every possible combination of artistic elements would be immediately available. The thrill of discovery would be replaced by the overwhelming burden of infinite choice. The paradox also raises questions about the role of the artist in creating meaning. We value artworks partly because they represent the artist's personal vision, their struggle to express something ineffable through material means. Frida Kahlo's self-portraits are powerful because they reflect her specific experience of pain, identity, and resilience. But in the infinite gallery, these same images exist independently of Kahlo's life story. Would they still carry the same emotional weight if they were simply random combinations of colors and forms that happen to coalesce into meaningful patterns? Does the artist's intention and biography matter, or does meaning reside entirely in the work itself? This connects to a deeper question about the relationship between limitation and meaning. Artists often say that constraints fuel creativity. A sonnet's beauty emerges partly from the challenge of expressing profound thoughts within strict formal limits. Haiku's power comes from capturing an entire world in just 17 syllables. The finite nature of human life, the specific historical moment in which an artist lives, the particular materials available to them, all of these limitations shape and focus their creative expression. But in the infinite gallery, all constraints are simultaneously present and absent. Every possible constraint has been explored, and therefore none of them retain their limiting power. Yet perhaps the paradox reveals something important about how we actually experience art. Maybe the meaning of art doesn't reside in its uniqueness or rarity, but in its capacity to resonate with human consciousness. Even in an infinite gallery, certain combinations of color, form, and composition would still move us to tears or joy or contemplation. The fact that infinite variations exist wouldn't diminish the power of the one that speaks to your particular heart. at a particular moment. Beauty might not depend on scarcity, but on the mysterious alchemy between artwork and observer. This paradox echoes Jorge Luis Borges' famous story, The Library of Babel, which imagines an infinite library containing every possible book. In Borges's library, every meaningful text exists alongside infinite volumes of meaningless gibberish. The complete works of Shakespeare are there, but so are versions where every word has been replaced with random letters. The problem becomes not finding information, but finding meaningful information within the infinite noise. Similarly, our infinite art gallery would contain every masterpiece alongside infinite amounts of visual noise, making the search for meaning itself meaningless. This suggests another resolution to the paradox. Meaning might be created not by the artwork alone, but by the relationship between art and audience. Each person brings their own history, emotions, and perspective to every encounter with art. Even if identical paintings existed in infinite variation, each individual's response would be unique. The meaning would emerge from the intersection of infinite possibility and finite human consciousness. Your response to a particular painting would be shaped by your specific life experiences, making that encounter irreplaceable, regardless of how many similar paintings exist. The paradox also illuminates the temporal nature of artistic meaning. Art gains significance not just from its formal properties, but from its place in the flow of human history. Guernica is powerful, partly because it responds to the specific horror of the Spanish Civil War. The Harlem Renaissance paintings matter because they emerged from a particular moment of cultural awakening. But in the infinite gallery, all artworks exist simultaneously, outside of historical time. Would art lose its capacity to comment on, respond to, or shape specific historical moments? The paradox might also suggest that the process of creation is as important as the final product. Even if every possible artwork already exists in the infinite gallery, the human act of creating, of struggling to bring something new into being, would retain its value. The journey of artistic creation, the growth it requires, the insights it provides, the connections it creates between artist and audience, all of these would remain meaningful, regardless of whether the end result is unique. Art might be less about producing unprecedented objects and more about facilitating human expression and communication. Perhaps the infinite art gallery paradox ultimately points to the importance of curation and context in creating meaning. In our finite world, museums, galleries, and critics help us navigate the vast but limited world of art. They provide frameworks for understanding, create connections between works, and guide our attention to what matters. In the infinite gallery, curation would become not just helpful, but essential for survival. Without some way to filter and organize infinite possibility, the gallery would become not a temple of art, but a nightmare of overwhelming choice. The reality verification paradox. Imagine you want to test whether reality is real. You devise careful experiments, gather evidence, make observations, and apply rigorous logical reasoning. But here's the puzzling catch. Every tool you use to test reality, every instrument you employ, every logical principle you apply, exists within the very reality you're trying to verify. Your eyes, your brain, your measuring devices, your mathematical equations, all are part of the system you're attempting to examine from the outside. It's like trying to lift yourself by pulling on your own shoelaces, or using a ruler to measure its own accuracy. Can you ever be certain of the results when your entire investigation takes place within the reality you're questioning? This is the reality verification paradox, the seemingly impossible challenge of using tools within reality to determine whether that reality is genuine, complete, or accurately perceived. It strikes at the heart of human knowledge itself, challenging our most basic assumptions about truth, evidence, and the possibility of certainty. Consider the fundamental problem. Every method we use to investigate reality presupposes the reliability of that same reality. When you look at an object to verify its existence, you're assuming your eyes work correctly, that light travels predictably, that your brain processes visual information accurately. When you use scientific instruments, you're trusting that the laws of physics operate consistently, that your measurements correspond to objective features of the world, that your instruments haven't been somehow compromised or deceived. When you apply logic and reason, you're assuming that logical principles themselves are valid and that your thinking processes are reliable. But what if reality itself is somehow deceptive or incomplete? What if you're living in a sophisticated simulation, like the Matrix from science fiction? The beings running the simulation could ensure that all your tests and experiments produce results consistent with what you expect from real reality. Your scientific instruments would work perfectly within the simulation. Your logical reasoning would proceed normally. Your observations would seem to confirm the reality you inhabit. Yet you would still be fundamentally deceived about the nature of your existence. The great philosopher René Descartes grappled with a version of this paradox when he imagined an evil demon who could deceive him about everything. This malicious being might create the illusion of a physical world, of other people, even of Descartes' own body, while only his thinking mind remained real. How could Descartes use his potentially deceived senses and reasoning to determine whether such deception was taking place? Any evidence he gathered could itself be part of the deception. Any logical argument he constructed could be undermined by the demon's manipulation of his thinking. The paradox becomes even more troubling when we consider modern scientific knowledge. Quantum mechanics suggests that the act of observation affects the reality being observed. The uncertainty principle implies fundamental limits to what can be simultaneously known. Relativity theory reveals that space and time themselves are not absolute but relative to the observer. If reality is this malleable and observer-dependent, how can we use scientific methods to determine its ultimate nature? We might be using curved instruments to measure curved space, creating a kind of cosmic circular reasoning. The circular nature of the problem runs even deeper. To verify that our logical reasoning is sound, we would need to use logical reasoning. To check whether our senses are reliable, we would need to use our senses to test our scientific instruments. We must need other instruments that we somehow know to be accurate. Each verification attempt seems to require assuming the reliability of the very things we're trying to verify. It's an epistemic hall of mirrors, where every attempt at independent verification leads back to the same circular dependencies. Some philosophers have tried to escape this circle by identifying certain undeniable truths. Descartes famously argued that "I think, therefore I am" represents one such certainty. Even if an evil demon deceives him about everything else, the very fact that he can doubt proves that he exists as a thinking being. But critics point out that even this apparently solid foundation might be questionable. How do we know that the experience of thinking proves the existence of a thinker? Could the sensation of doubt itself be an illusion, created without any real doubter behind it? The reality verification paradox becomes particularly acute in our digital age. Computer simulations can now create convincing virtual worlds. Artificial intelligences can generate realistic conversations, and deepfake technology can fabricate seemingly authentic evidence. How would you know if you're interacting with a real person or a sophisticated AI? How would you distinguish between authentic video evidence and artificially generated content? The tools we might use to detect such deceptions are themselves digital technologies that could theoretically be compromised or deceived. But the paradox isn't just about external deception. It also applies to the internal workings of consciousness and perception. Neuroscience reveals that our brains construct our experience of reality rather than passively receiving it. Our perceptions filtered, interpreted, and modified by our neural processes before we become conscious of them. The colors we see, the sounds we hear, the emotions we feel, all are in some sense creations of our nervous system, rather than direct reflections of external reality. How can we use this constructed consciousness to verify the reality it constructs? The paradox also challenges our understanding of knowledge itself. If we can't independently verify reality, what does it mean to claim knowledge about anything? Perhaps all human knowledge is necessarily tentative, contingent, and limited by our perspective within the system we're trying to understand. This doesn't necessarily make knowledge worthless, but it might make absolute certainty impossible. We might be forever trapped within our own epistemic horizon, able to make progress within our framework of understanding, but never able to step outside it for an objective view. Yet there's something paradoxical about this conclusion too. If the reality verification paradox shows that we can't be certain about the nature of reality, then how can we be certain about the paradox itself? The argument that circular reasoning can't provide certainty is itself a logical argument that we accept using our reasoning abilities. If our reasoning is unreliable, then the paradox might be false. If our reasoning is reliable, then perhaps it can provide some genuine insight into reality after all. Some philosophers suggest that the paradox dissolves when we recognize that complete verification was never the goal. Science doesn't seek absolute certainty, but rather increasingly accurate and useful descriptions of observable patterns. Truth might not be about correspondence to some objective reality beyond all investigation, but about coherence within our best current understanding. From this perspective, the reality verification paradox doesn't undermine knowledge, but rather clarifies what kind of knowledge is actually possible and valuable. Others argue that the paradox reveals something profound about the nature of existence itself. Perhaps reality is not the kind of thing that could be verified from the outside because there is no outside. Reality might be self-contained, self-validate, and self-revealing in ways that make external verification both impossible and unnecessary. Search for verification might be based on a mistaken picture of reality as something separate from our experience of it. The pragmatic response to the paradox focuses on what actually matters for living and acting in the world. Whether or not we can verify reality with absolute certainty, we still need to make decisions, form beliefs, and navigate our environment. The methods we use, circular though they may be, seem to work well enough for practical purposes. Our science builds better technology. Our reasoning helps us solve problems. Our senses guide us safely through the world. Perhaps the consistency and usefulness of these circular methods is the best kind of verification we can hope for. But the reality verification paradox refuses to be completely domesticated by pragmatic considerations. It continues to raise deep questions about the foundations of human knowledge and the nature of existence. Are we forever trapped within our own perspective, or are there ways to transcend the limitations of self-referential verification? Could there be forms of knowledge that don't depend on circular reasoning? Might reality itself provide us with ways to verify its authenticity that we haven't yet discovered? The paradox also connects to questions about consciousness and the hard problem of understanding subjective experience. If consciousness is what makes verification possible, then understanding consciousness might be key to understanding the limits of verification. But consciousness studying itself faces the same circularity problems as reality, verifying itself. The observer and the observed, the verifier and the verified, seem to be entangled in ways that make independent assessment impossible. In the end, the reality verification paradox might not be a problem to solve, but a mystery to live with. It reminds us that human knowledge is always knowledge from a particular perspective, using particular tools within particular limitations. This doesn't make our knowledge worthless, but it does make it humble. We are beings who can ask whether reality is real, even if we cannot answer that question with absolute certainty. And perhaps that capacity for questioning, for wondering about the foundations of our own existence, is itself one of the most remarkable features of the reality we inhabit. Whether that reality is ultimately verifiable or not,